Solo riwayatmu ini sedari dulu jadi perhatian insani. Spojrzał Allah w to, a gdy nie ujrzał dna, wnet popatrzył w twarz księżyca i podniósł w górę kłam i wstąpił w czarne fale i wstąpił w parnej nocy senne mgły, a gdy zanurzył stopy palec, tam rosły brzegi wysp i tu porachu. Riwayatnya dulu
湾索隆，永远不改模样。只有旧情人，他不再偎依在我身旁。Bengawan Solo, riwayatmu ini sedari dulu jadi perhatian insani.
Musim kemarau terus airmu, di musim hujan air meluap sampai jauh.
Mata airmu dari Solo terkurung gunung seribu. Air mengalir sampai jauh, akhirnya ke laut.
Itu padamu riwayatmu dulu.
Kaum pedagang selalu naik itu perahu. Pam, pararau, pam, pam. Pam, pam, pararau, pam, pam. Pararau, pam, pararau, pam, pam. Mata airmu dari Solo terkurung gunung seribu. Air mengalir sampai jauh, akhirnya ke laut.
Akhirnya tahu itu padaku riwayatmu dulu.
Kaum pedagang selalu naik itu perahu. Kaum pedagang selalu naik itu perahu.
No.
Kasih.
Bengawan Solo, 흐르는 강물은 언제나 변함없이 따스하게 늘 지켜준 메마른 가뭄에 속 타던 날들이 시원한 비자 Bengawan Soloลือซอตั้งหอแต่ชงายแดนเตสพีบแดงลายซอพรชาติชายแสนสายจวบจันขยมBengawan Solo
Bengawan Solo, din saga känner vi, ifrån forna tider strömmar minnen med dig förbi. Och när torr tid rår, din ström då stilla går, men när regnen kommer långt i havet ditt vatten når, du framåt glad och lycklig rinner,
av tusen berg och skog omgiven.
Många bäckar små dig finner, din famn är stor och vit. Båtar stora små, det på ditt vatten går. Du har alltid varit god, oss hjälpt att varandra nå.
Bengawan
Solo,
din saga känner vi,
ifrån
forna tider strömmar minnen med dig förbi. Och när torr tid rår, din ström då stilla går, men när regnen kommer långt i havet ditt vatten når, du framåt glad och lycklig rinner,
av tusen berg och skog omgiven.
många bäckar små dig finner,
Din famn är stor och vid,
båtar stora små.
båtar stora små.
Det på ditt vatten
Det på ditt vatten går.
Du har alltid varit god, oss hjälpt varandra nå.
Du framåt glad och lycklig rinner,
Av 1000 berg och skog omgiven.
många bäckar små dig finner. Din famn är stor och vid, båtar stora små.
Båtar stora små.
Det på ditt vatten går.
Det på ditt vatten går. Du har alltid varit god, oss hjälpt varandra nå.
Bengawan Solo, riwayatmu ini sedari dulu jadi perhatian insani. Musim kemarau, tak berapa airmu di musim hujan, air meluap sampai jauh. Mata airmu dari Solo berkurung gunung seribu. Air mengalir sampai jauh, akhirnya ke laut. Itu perahu, riwayatnya dulu. Kaum pedagang selalu naik itu perahu. Mata airmu dari Solo berkurung gunung seribu. Air mengalir sampai jauh, akhirnya ke laut.
Bengawan Solo, riwayatmu ini sedari dulu jadi perhatian insani. Spojrzał Allah w to, a gdy nie ujrzał nas, wnet popatrzył w twarz księżyca i podniósł w górę dłoń i wstąpił w czarne fale i wstąpił w parnej nocy snem mgły. A gdy zanurzył stopy palec, tam rosły brzegi wysp akhirnya ke laut. Daunam Allah łzy, a my nie chcemy łez. Kaum pedagang selalu naik itu King Empress.
Banggawan Solo， 美丽像花一样，风帆一片片在水上不停地来游望。Banggawan Solo， 仿佛是在梦乡。
Bengawan Solo, riwayatmu ini sedari dulu jadi perhatian insani.
Musim kemarau terserah airmu, di musim hujan air meluap sampai jauh.
Mata airmu dari Solo terkurung gunung seribu. jauh, akhirnya ke laut.
Itu padaku riwayatmu dulu.
Kaum pedagang selalu naik itu perahu.
Kita boleh makan. Boleh. Kalau di bani, Pak. Sini, Mak. Sini. Sini.
Mata airmu dari Solo,
Pasnya.
gunung-gunung seribu, air mengalir sampai jauh, akhirnya ke laut.
Itu padaku riwayatmu dulu.
Kaum pedagang selalu naik itu perahu. Kaum pedagang selalu naik itu perahu.
No.
Bengawan Solo 흐르는 강물은 언제나 변함없이 따스하게 늘 지켜주 내 마른 가뭄에 속 타던 날들이 시원한 비 찾아와 멀리 넘쳐 흐르네. 고향 떠난 솔로의 샘물 굽이굽이 흘러넘치며
Halo anak.
천 개의 산을 감아돌아 바다에 이르네. 저기 가는데 세월 따라 흘러
morning, Prof. Arimura.
How
are you today?
Yeah, I'm fine. How are you?
Yeah, I'm fine.
I hope everything is well.
Anyway, thank you for organizing.
Oh, thank you very much. You're
Yeah,
welcome.
this workshop and thank you for preparation.
Yeah, yeah, thank you.
Thank you very much.
លឺសទំហរទៅឆ្ងាយដែនទេសភាពទាំងឡាយសោភ័ណ្ឌឆើតឆាយសែនស្ដាយជាប់ចិត្តខ្ញុំបង្កាវ៉ាន់សូឡូទាំងហោថ្នោសូរងំជួយលួងលោមអារម្មណ៍សែនសុខសុខខំពេលដែលខ្ញុំបានយល់អោបង្កាវ៉ាន់សូឡូអើយ
Oh, tomato. Sorry, thank you very much.
Good morning, Prof. Sasaki.
Good morning, Dr. Anand. Thank you for organizing.
Yeah, you're welcome. Thank you very much for your
Very
collaboration.
wonderful. A very wonderful workshop. It's a very timely topic, I think.
Thank you, thank you.
Anand, I'd like to see. I forgot the name.
From
Dean of your department.
Panji, Dr. Panji.
No. Yes.
I think he has come here. Dr. Panji.
Not Dr. Panji. I think.
Prof. Muhammad Nur.
No. Today's greeting person. Just a moment. I forgot his name.
Zainal. Dr. Zainal.
Widowati.
Oh, Prof. Widowati.
Yeah.
Prof. Widowati.
He's coming?
I hope he has coming here.
Okay. Because maybe Professor Sasaki want to see him before opening.
Yeah. Professor Heri Sutanda.
Ohayo gozaimasu, Sensei.
Ohayo gozaimasu. Thank you very much.
Thank you very much. Yeah. Nice to meet you in Semarang.
Okay.
Yes.
Thank you very much. This nice workshop and collaboration with us.
Thank you. Okay.
Thank you.
Professor Sutanta is head of department of physics.
Okay. Thank you very much.
Okay.
And, by the way, Anna, could you introduce Stanto to Professor Sasaki?
Yeah.
Yes.
Professor Stanto, maybe you can introduce yourself to Professor Sasaki.
Yes. Thank you, Mr. Anam. Yes, Professor Sasaki, Sensei Sasaki.
Good morning.
Good morning, Prof. Sasaki. Thank you for your time and to collaboration with our university, especially is physics department. In the next time, we hope that the close collaboration, the QC University, especially in the Faculty of Medicine Science QC University. Thank you, Sensei. Okay.
Yeah, nice to meet you, Dr. Sutanto. Thank you very much for organizing this wonderful workshop. We are very pleased to collaborate with the university. Yeah.
Thank you.
Thank you very much.
Thank you very much.
先生、ありがとうございます。
いえ。本当は行きたかったですよね。
So we'd like to go there,
Yeah.
Indonesia.
Yeah. We hope the pandemic will be end in the next year, so we can move to Japan.
Yeah.
Actually, in the next year, if the pandemic will end, I will visit Kyushu University again.
Oh, good.
Yeah.
We'd like to welcome you. All
Thank
of
you
you.
very much.
We hope so too.
Yeah.
Okay. And
Good morning, Professor Fuji.
Yeah.
Good.
Good morning.
Good morning, Professor
Nice to meet you
Puji.
again.
Yes.
Good morning, Professor Widawati.
Good morning, Dr. Hendra.
Good morning, Prof. Widawati.
Good morning,
Professor Sasaki
Heri.
has come here.
Yeah.
Oh, good morning, Prof. Sasaki.
And Prof. Arimura and Prof. Fuji.
Prof. Arimura.
Okay. Hello.
Nice to meet you, Ms. Professor Widwati. Yeah. Thank you for.
Nice to meet you too, and welcome to the Diponegoro University again, especially for Professor Fuji. Last year you joined also with our event in physics department.
Thank you very much. We do want to visit Diponegoro University.
Bisa datang semua ya. Iya. Saya pikir tadi itu semua datang. Oh ini hanya pembukaannya. Oh ternyata dia bagi dua gitu. Saya nggak perhatian.
Anang?
Yes, Prof.
How many female faculty members do you have in your department?
Female. We have one Dr. Murah, Dr. Sumaria, Dr. Eis, and Dr. Effie. Four.
Oh.
4 faculty members.
4.
Yeah, 4.
Very nice. Yeah, equally gender opportunity.
Yeah. And actually, I never see the female faculty in Kyushu University.
We are recruiting now.
Excuse me, ladies and gentlemen. Please prepare yourself to join our workshop because our workshop is about to begin. And please enter from absensi Wahaseng in the room chat book of this workshop. Thank you. Tuh.
Miss Indah and Miss Rahma, are you ready? Okay, ready? Okay.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, audience.
Good morning, Waalaikumsalam warahmatullahi wabarakatuh.
Ladies and gentlemen, welcome to the first day of IndoseCT and PHITS.
Kemudian Jawa Timur aja bilang anggap aja ada kok.
Oh, thank you.
Rama, sound Jeremy.
I'm Anugrah Rama and my partner Indra Jasmita Anwar, your master of ceremony in this morning.
We would like to thank everyone here for taking time to attend our remarkable workshop.
His Excellency, Mr. Dr. Khairul Anam, SSC, MSc, and Mr. Prof. Dr. Tosios Pujipusi, our speaker of workshop 25 to 26 September 2021.
Honorable the Dean Faculty of Science and Mathematics, Diponegoro University, Mrs. Professor Dr. Widowati, and the Dean Faculty of Medical Sciences, Kyushu University, Mr. Professor Dr. Masayuki Sasaki.
Respectable the Chair of Physics Department, Professor Sutanto SSC MSc. And respectable all commit and participant in this workshop. Okay, before we go to the next session, let's start by singing the national anthem Indonesia Raya.
Indonesia tanah airku. Darahku di sanalah aku bertinggi pandu.
Menyampaikan bahwa terlempar keluar.
Okay, thank you very much. Next, let me conduct the rules of this workshop. First, rename your account name with the name _ agency format when joining the Zoom room.
Second, participants are requested not to activate the microphone feature during the webinar activity.
During the webinar, participants are required to activate the camera feature with the virtual background as sent in email and the Zoom chat box.
Next, a Teams link will be sent in the Zoom chat box.
Participants can ask the research persons in the Q&A session by using the Zoom chat box with the format name _ origin of region _ agency _ question, or raise your hand and activate the microphone feature.
Next, moderators have full right to organize the webinar.
Second, we will send the webinar material via email and/or Telegram group at the earliest on H+1 webinar.
And the last, we will send the certificate no later than H+7 of the webinar, calculated from the second day of the workshop via email.
First of all, thanks to God who has given us some mercies and blessings so that we can attend this workshop without any troubles and obstacles.
Before we go to the workshop, allow me to read today's agenda. The first agenda is opening with prayer. Secondly, speech from our honorable. Turn, remark or speech from speakers, and the last closing by prayer. Those are the today's agenda, which will be presented soon.
Dear audience, ladies and gentlemen, let's open this agenda by prayer. Praying begin. Pray, Amin, pray enough. Thank you very much.
Okay, audience, moving into our second agenda, which was a speech from the chairman of Physics Department for Mr. Heri Sutanto. Please welcome.
Bismillahirrahmanirrahim. Thank you, Ms. Anutullah Rahma, as Master of Ceremony, for giving me a time to keep welcoming speech the workshop. Our Honorable Dean of Faculty of Medical Science Kyushu University, Professor Dr. Masayuki Sasaki, the Dean of the Faculty of Science and Mathematics, Professor Dr. Widowati, Professor Dr. Hidetaka Arimura from Kyushu University, our visiting professor, Professor Dr. Toshio Fujibuchi from the Division of Medical Quantum Science, Kyushu University, the speaker from Diponegoro University, Dr. Khairul Anam, and all participants of the workshop. Assalamualaikum warahmatullahi wabarakatuh. Good morning and ohayo gozaimasu. Welcome to the IndoseCT and PHITS modeling workshop organized by the Physics Department, the Faculty of Science and Mathematics, Diponegoro University, Indonesia. This workshop is a part of a long-term program of the Physics Department to promote competence and achieve international achievement. We always welcome international visiting professors to share their expertise to enhance research and education in the Physics Department. Professor Puji contribution to our department is well known for this research and publication collaboration with our lecturers. His participant in an international conference held by the faculty and his lecture at the Indonesian Medical Physics annual meeting in Semarang also enlightened us with recent technology to improve patient care. We record more than 300 participants follow this online workshop from various university, hospital, and government institutions in Indonesia. Moreover, academia and professionals from international institutions also register for this workshop. We sincerely hope that this workshop will improve the technical and theoretical aspect of medical physics analysis. We support and promote further collaboration between the Physics Department and the Division Medical Quantum Science, Kyushu University. We hope the enhanced cooperation with student and staff exchange with Kyushu University in the future. And the end, this speech on behalf of the staff of the Physics Department, I thank Professor Sasaki for your attendance and Professor Puji for your contribution to this workshop. To all participants, please enjoy the workshop and improve your expertise as much as possible. Thank you very much. Arigatou gozaimasu. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Prof. Heri, for the welcoming speech for today.
Next speech will be delivered by our honorable guest star, Mr. Masayuki Sasaki. For Mr. Masayuki, time is yours.
Thank you very much for wonderful welcome speech, Professor Tanto. I'm Dr. Masayuki Sasaki, a Dean of Department of Health Science, Kyushu University. Minasan, ohayo gozaimasu. Good morning, ladies and gentlemen. It's a great pleasure. It's a great pleasure to hold the online webinar, IndoseCT and PHITS modeling workshop. First of all, I would like to say thank you to Dr. Anand, Professor Fujibuchi, and all of you for preparing this online workshop. I also want to say thank you to Professor Widuichi for your cooperation. International communication in the field between Diponegoro University and Kyushu University started at 2016 with Dr. Anand's stay at Fujibuchi Lab in Kyushu University. His stay was just 3 months, but he worked hard and left important footprints. In 2019, Miss Yulia Ildawachi also stayed in Fujibuchi Lab. In 2018 and 2019, Professor Fujibuchi, some faculty members, and some graduate students of Kyushu University visited Diponegoro University. We appreciate for your warm welcome and active discussion. In 2019, we invited Professor Muhammad Nur, Dr. Anna, Dr. Pandi Triadisaksa, Dr. General Arifin to the 15th International Forum of Health Science in Kyushu University. They kindly provided wonderful lectures and we had a lively discussion. This meeting enhanced our partnership, I believe. Today, we are very pleased to hold the online webinar IndoseCT and PHITS modeling workshop. This is a timely topic and it's very important to us. Recent global interest in medical radiation exposure has been growing. The establishment of the highly precise method for theoretical evaluation and real measurement is necessary. I believe today's workshop will be a great help and will improve your skills in this field. Please enjoy today's workshop. Thank you very much. ありがとうございます。
ありがとうございます。Masayuki Sensei.
Thank you, Mr. Masayuki Sasaki, for the wonderful welcoming speech.
Okay, the speech will be delivered by the Dean Faculty of Science and Mathematics, Diponegoro University, Mrs. Professor Dr. Widowati. Please welcome.
Thank you very much, Master Ceremony. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
And good morning, ladies and gentlemen.
Morning.
Excellency, the Dean of the Faculty of Medical Science, Kyushu University, Professor Dr. Masayuki Sasaki, our visiting professor, Professor Dr. Joseph Fujibuchi from the Division of Medical Quantum Science, Kyushu University, Japan. Excellency, Professor Hidetaka Arimura, Professor Dr. Wahyu Setiabudi, Professor Dr. Jarwani. Thank you for your joining in this event. Honorable, the head of physics department, Diponegoro University, Professor Dr. Heri Sutanto, the speaker from Diponegoro University, Dr. Khairul Anam, dear lecturer at Department of Physics, and all participants of the workshop. First of all, let us give thanks for the presence of Allah Subhanahu wa Ta'ala, the most gracious and merciful God, because with His permission today, we can gather here to join together for the online IndoseCT and particle and heavy ion transport code system modeling workshop events. We are pleased to cordially welcome Professor Sasaki, Professor Fujibuchi, and all participants to the IndoseCT and modeling workshop organized by the physics departments the Faculty of Science and Mathematics, Diponegoro University, Indonesia. The Faculty of Science and Mathematics aims to support research and education developments in basic and applied sciences. Several workshops and visiting professor program have been implemented to promote Diponegoro University as a world-class university. We also support our students to gain an international atmosphere by conducting research and short-term study in other international universities. Therefore, we always welcome international cooperation and collaboration to enhance mutual advantages in research and education. We have known Professor Fuji for several years from his activities as the visiting professor in our faculty and research publication with our faculty members. We sincerely hope that the modeling workshop will be followed by more significant events such as joint classes or summer courses in our faculty. We actively support the prospect of formal cooperation between the Faculty of Science and Mathematics, Diponegoro University, with the Faculty of Medical Science of Kyushu University, Japan. We sincerely thank Professor Fuji for his attendance and significant contribution to promoting sciences and technology at Diponegoro University. We hope this workshop can inspire many scientists to improve their research and open broader international collaboration between institutions. Last but not least, by the grace of God Almighty and consent of all participants, on behalf of Faculty of Science and Mathematics, Diponegoro University, I am as a Dean hereby announce that IndoseCT and Vertical and Heavy Ion Transport Code System Modeling Workshop is open. I encourage all participants to participate actively in the interesting discussion. Hopefully, what we are doing today is useful for our progress in the future. Thank you very much for your kind attention. Arigato gozaimasu. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Mrs. Widowati, for your welcoming speech. Okay, we move for the next session. Dear audience, ladies and gentlemen, we have finished our opening. Before we move to the next session, I would like to invite you to take pictures together. So please activate your camera feature.
Okay, please prepare your smile as beautiful as possible to get good result. And I will count one until 3, and the commit will document. Okay, be ready. Okay. 1, 2, 3. Okay, once again. 1, 2, 3. Okay, thank you.
I would like to invite Mr. Fajar to moderate the workshop today. For Mr. Fajar, time is yours.
Okay. Thank you, Miss Indah and Miss Rahma. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. Excellencies, distinguished guest delegates, speakers, and ladies and gentlemen, dear for the all participants of this workshop. Ladies and gentlemen, allow me to introduce myself. I'm Fajar Arianto, the moderator of today's workshop. I'm very happy to see you here and welcome all of you to this workshop. Today's workshop is about IndoseCT modeling. Ladies and gentlemen, our speaker today is Dr. Khairul Anam. He is one of the lecturers at Department of Physics, Faculty of Science and Mathematics, Diponegoro University. Khairul Anam completed his PhD in Physics Department, Institute of Technology, Bandung, in 2018. He received Master for University of Indonesia in 2010 and the Bachelor of Science from Department of Physics, Diponegoro University in 2001. He is currently working as lecturer and researcher in the UNDIP. His research interests in image reconstruction, medical imaging process, and dosimetry for diagnostic radiology, particularly in computed tomography or CT. He has authored and co-author of 150 scientific papers. In the last 5 years, he was the first author of 40 papers in peer-reviewed scientific journals. He is a reviewer in many reputable medical physics journals, such as Medical Physics, Physics in Medicine and Biology, Journal of Applied Clinical Medical Physics, Physica Medica, European Journal of Medical Physics, Australasian Physical and Engineering Sciences in Medicine, Journal of Digital Imaging, Biomedical Physics and Engineering Express, Journal of Medical Imaging and Radiation Oncology, Radiological Physics and Technology, and Journal of X-ray Science and Technologies. He is an editor-in-chief of Berkala Fisika and Berkala Fisika Journal, and a member of the editorial board for Journal of Medical Physics and Biophysics. One of his papers published in CheckIMP had been awarded as the best medical imaging physics article in 2016. He was also recognized as an outstanding reviewer for PMB in 2018 and BPEX in 2019. He was also awarded as the ZIVOM Young Leader Awards 2019 from the Southeast Asian Federation of Organization for Medical Physics. Before the presentation starts, let me tell you how the presentation will go. First, the speaker, Dr. Khairul Anam, will be invited to present the material. After that, there will be a question and answer session followed by a conclusion. Now, allow me to welcome the speaker, Dr. Khairul Anam, to make his presentation. To Mr. Dr. Khairul Anam, please explain the material. This time is yours, please. Thank you.
Thank you, Mr. Fajar. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Excellencies, Professor Widawati, Professor Masayuki Sasaki, my professor, Professor Arimura Sensei, Professor Fuji, Professor Jarwani, Professor Wahyu Setiabudi, and all participants. Thank you very much for joining this workshop. Okay, allow me to present our presentation. Okay. Okay. Today, in this workshop, I will present on dosimetry in CT. This is an overview of this workshop for today. The one is introduction, cancer risk, and the second will be multiple scan. We will introduce metric in the dose in the CT scan, such as multiple scan average dose, MSAD, and then CT dose index, CTDI, dose length product, DLP, and then site-specific dose estimate, SSDE. And after we introduce the metric of the CT, we will move to the IndoseCT. The first one, we will download the IndoseCT, and then we will applicate IndoseCT to calculate the all of metric in the CT dose, such as CTDI, DLP, and SSDE. And I hope everyone, for every participant, have downloaded the IndoseCT file. However, if you didn't download it, the file, we will download together and install together, and then we will applicate the IndoseCT together, and we discuss. Yeah, we hope we will finish our workshop today before 1 p.m. I hope. But if we end faster, is better, I think. Yeah. Okay, thank you. If we move to the introduction for the CT, we know that the use of CT scanner is continually increasing year by year, because we know that the CT provide high quality image in 3D with very fast acquisition. This is the one advantage of CT over the other medical imaging, such as MRI and so on. The CT, the image quality is very high, and the acquisition time is very fast. Therefore, the CT is usually used for the medical purposes. And many parameters to for the quality of the images of CT, such as high spatial resolution, low noise level, and also high very low noise. However, CT scan is considered as the powerful modality, but unfortunately, CT contribute most of the medical dose experience by the patient. Both reported the thorax, for example, the effective dose from the CT was about 5 to 7 millisievert, while from the conventional X-ray was only 0.1 to 0.2 millisievert. So the dose of CT is around 50 times or more compared to the conventional X-ray. Therefore, the dose of CT is considered very high in the radiology. And this is data from the Europe. Although the CT contribution is only 7%, however, the dose contribution up to 60%. So the dose of CT is a very, very high concern because the very high dose and give the most of the total dose in the radiology. And this is the risk. And this is the correlation between risk and dose. We know that the risk is proportionally linearly correlated to the dose. It means that if the dose increase, then the risk will be increased. And there are many models, but the most well-known model is L-anti model, linear no threshold model. It means that the dose at the risk linearly increase with the increasing of the dose. Because the CT dose is very high, therefore the dose of CT is very, very concerned in the world. And many effort to decrease the dose of the CT scan. And this is the estimation, the risk estimation of the CT. This is from the journal of the New England Journal of Medicine, written by Professor Brenner and Professor Hall. This is the estimated lifetime attributable risk of death from the cancer from the CT examination. We see here that the estimated lifetime attributable risk increase with the decreasing of age of the patient. We can see here for the newborn patient aged from 0 to 1 year, the risk is very high, about 0.1%. It means that every 1,000 pediatric patient treated with the CT scan, the one of them will be get the risk over their lifetime. And the risk is the decrease with the increasing of the age of the patient. For the adult patient, the age maybe about 40, the risk is about 0.01 to 0.02, very, very low compared to the very young patient. However, the examination using CT scan is very high. This is the data from the US. In the US, in the 2008, I think, there are more than 62 million examinations in 1 year for adult, and more than 4 million in 1 year for the children. And if we calculate the risk of the cancer from this population like this, 4 million multiplied by 0.1% will be 4,000 children. 4,000 children will be have risk after CT examination. And for adult, the 62 million multiplied by 0.01% will be 6,000. It means that about 10,000 people will have cancer after CT scan every year. This is only in the US. I think in Indonesia, in Japan, also similar, because the population is very high. Therefore, the risk of the CT scan is very, very concerned for us as scientists, and we work and we have evolved how to decrease, how to reduce the dose to the patient. It is true that the risk is very small for individual, as we said. However, the risk is very large for population. We notice that more than and about 10,000 people in US will have cancer from the CT examination. This is also epidemiologic study from Matthews, and Matthews also reported the similar result, that the CT, the risk of CT is about 0.1 for adult and 0 for pediatric, and 0.01 up to 0.02% for the adult patient. This is the similar report from the peers in the Lancet in the 2012. One access per 10,000 in head CT scan, also similar. Therefore, the optimization of the CT is very, very important. We should reduce the dose as low as possible while maintaining image quality to diagnose the abnormalities. And to facilitate the dose optimization, therefore, the CT dosimetry is very, very important. And the availability of the software is also very important. Therefore, we develop such kind of software in the CT. Okay, we move to the next parameter of the CT dose. The first metric introduced in the CT is the multiple scan average dose, MSAD. This is the first one, the first metric introduced in the CT dosimetry. As we know that the CT, the source of CT is X-ray, and then X-ray is from the every angles around patient from 1 degree up to 360 degrees. And this is the slice of the X-ray beam like this. And as we know that the dose is not strictly limited in this region, but actually the dose is broadened. The dose has a Gaussian shape, and if the scan repeated every slice from one slice to another slice, therefore the tail of the dose from every slice will be affect to the next slice. Therefore, the dose in one slice is sum from the primary dose and a secondary radiation from the adjacent slice. Therefore, in the CT scan, we cannot also put one detectors to monitor the dose of CT. And the first metric introduced is MSAD. MSAD is like this. This is the profile of dose for every slice. However, if the scan is repeated in every slice, and then the cumulative dose from multiple scan will be high, like this. In the mathematical perspective, the total dose is the convolution between the every profile in every position, and then we get like this. The dose in the specific position will be higher than dose from only single slice. Therefore, the multiple scan average dose is introduced to accurately monitor the dose of CT scan. In the beginning, the dosimetry of CT by using TLDs. We use many TLDs, and we located the every TLDs in every position, and then we scan the patient or phantom more than 10 slices, and then we get the doses, and then we average it in the middle position of the scans, and then we get the MSAD. Therefore, the MSAD is not effective, because in the beginning of the CT scan, the time of scan is very long. Maybe one scan is more than, I think, more than 1 minute, and the handle of the TLD is need more time, I think. So to get the MSAD is very long time. Therefore, the MSAD is considered not effective because it takes a longer time. This is the limitation of MSAD. And therefore, in the 1981, the concept of CT dose index is introduced in the USA by the Professor Shaw. In the CTDI measurement, we not use multiple scan, but we only use one scan, and we don't use TLD. Instead, we use a long ion chamber. The long ion chamber has a length of 10 centimeter or 100 millimeters. And then we scan one slice, only one slice. And from this measurement, we get actually the integral of dose like this. This is the integral dose measured from the pencil ion chamber. Has active length of 10 centimeter. And if we divide the integral dose by the beam width, fortunately, we get the CTDI value, and this value, CTDI, is fortunately similar to the MSAD. Therefore, the CTDI is considered very effective way to measure, to obtain the MSAD. Yeah, this is the pencil ion chamber. It has active length of 100 millimeters, and the measurement use phantom. There are two types of phantom: body phantom with 32 centimeters and head phantom with a diameter of 16 centimeter. Like this. It's very, very simple and very fast to get the CTDI. This is the result from the professorship and published in the Medical Physics in 1981. All of you can download this paper. It is very interesting. If scan more than one slices, generally, the MSAD will be similar to the CTDI. However, for the scan less than 10 slices, the MSAD actually higher than CTDI. However, in the modern CT scanner, I think the slices always more than 10 slices. Therefore, the CTDI is considered very accurate metric to characterize the dose from the CT scan. And then CTDI replace the MSAD. MSAD is no longer used in the world, in Indonesia, in Japan, in USA. To characterize the dose, we use CTDI. And actually, there are many derivatives from the CTDI, such as CTDI 100, CTDI central, CTDI peripheral, CTDI weighted, CTDI volume. And now in the modern CT scanner, the CTDI volume should be on the screen console of the CT scanner. I think after 2010 maybe, every CT scanner should display the CTDI volume in the CT console. And this is the derivative of the CTDI, the FDA. The dose integrated from the 7 slices of before middle scan and 7 slices after middle scan, and then divided by the beam collimation. However, this FDA is not longer used. Now, the CTDI used is CTDI 100. The integration is not from 7 slices, but from minus 50 millimeters up to plus 50 millimeters, and we get 100 CTDI 100. It means that the integration have been conducted in the 100 millimeters, and the integration of those, if the divided by the T beam width, we will get the CTDI 100 like this. Is it long enough? Actually, no. Actually, no. And nowadays there is many research to investigate and overcome the limitation of CTDI 100. And we know that the dose is not uniform in the phantom, especially in the body phantom, which is have 32 millimeters in diameter. The dose will be lower at the center, and the dose will be higher at the peripheral position. Therefore, the CTDA weighted, CTDA average is introduced like this. The CTDA weighted is the CTDA 100 multiplied by this one, and plus by CTDI 100 in peripheral multiplied by 2/3 like this. This is the CTDA weighted. And actually, after the introduction of the spiral CT or helical CT, the CTDI weighted is also used to characterize the CT dose. However, the CTDI W weighted is corrected by the pitch, like this. CTDI divided by pitch, we get the CTDI volume. Therefore, the CTDI volume is considered as the average dose in the X, Y, and axis. In the X, Y, and Z axis. CTDI volume like this. This is the limitation of the CTDI 100 because the CTDI 100 is considered too short to capture all doses from the patient. And today we will not discuss limitation of CTDI 100 based on the length. We move to another. Okay. If you want to more understanding about how much long if the phantom should be used in the CT dosimetry, you can refer to this report by the AAPM published in 2010. The comprehensive methodology of the evaluation of radiation dose in X-ray computed tomography. And this is the in the APM 210, the dosimeter is not a pencil chamber instead of the small ion chamber, and the examination is not using one slice, but using the helical modes to measure the CTDI using small ion chamber. And this is the dose length. If we multiply the CTDI volume with the scan length, and then we get the DLP, dose length product. The DLP provides an indicator of total radiation detriment in the patient. And the DLP, this DLP is very, very important for estimating effective dose. If we want to estimate the effective dose, it's not only using CTDI volume, but we should use the DLP instead. Okay. And then we move to the more recent metric, site-specific dose estimate. This metric is introduced in the 2011 by the AAPM. This is the paper from the Professor McCullough. This is the question. Is the CTDI accurate from estimating patient dose? Have very specific diameter for very specific size? The answer, no. The CTDI and patient dose, actually, they are not the same thing. The CTDI is only metric for estimating the output dose, not for the patient. If we want to identify the dose received by the patient, we not only consider the output dose, but we also consider the specific of patient. His size, his composition should be considered if we want to get the more accurate dose estimation. Yeah. The CTDI volume only depend on the input parameters such as KV, MA, secondary rotation time, pitch, slide thickness, and so on. However, if we want to estimate the patient dose, we not only depend on the output dose, but also depend on the patient characteristic. Therefore, in the AAPM, in the 2011, AAPM introduced the new report and introduced the new metric called as the size-specific dose estimate. And in the SSDA, the CTDI volume should be corrected with the size of the patient. And this is the normalized dose coefficient introduced by the AAPM. This is the x-axis is effective diameter from 10 centimeter up to 45 centimeter. For example, if the patient has size about 32 like this, and then the normalized dose coefficient is 1. So the CTDA volume will be similar to SSDE will be similar to the CTDA volume. However, if the patient scanned with the same parameters, the same KV, the same MA, the same rotation time. However, if the size of patient is smaller, for example, for the pediatric patient, maybe they have, for example, 15 diameter, 15 centimeter, and then we get here the normalized dose coefficient will be about 2. It means that the dose of patient in SSDE will be twice compared to the CTDI volume. This is the SSDA metric considered is more accurate for estimating the patient dose. And the CTDA volume is only metric for characterizing the output dose of the patient. Okay, we move to the patient characteristic. There are many patient characteristics. Patient size, this is the more important. And the patient size, and there are many ways to estimate the patient size. Based on weight or BMI, age, or geometrical size, such as diameter in lateral direction, in AP direction, or combination AP and lateral, and the effective diameter. This is the patient characteristic. However, this geometrical size is only considered the geometrical size and not consider the attenuation of the patient. And as we know, the dose of the patient is very, very depend on the attenuation of the patient. Therefore, the other metric to estimate the patient size is also introduced. And the name is water equivalent diameter, TW. Okay, and we, inshallah, will calculate this parameter easily using IndoseCT. Okay, this is the example of the conversion factor come from the AAPM 211. This is for the lateral and AP. For example, if the patient has the 20 diameter in lateral and AP, the effective diameter will be 9.7, and the conversion factor will be 1.29, like this. And this is the table 2B lateral, and the table 2.3 is AP, and this the table 2D is effective. This table is come from the APM report 2004, published in the year 2011, and this is the age. The effective diameter is not linearly increase with the increasing of the age patient. We can also use the age of the patient to predict the effective dose. However, this prediction is, I think, the less accurate compared to another metric such as diameter of the patient. This is another publication related to the age of the patient and the diameter of the patient, such as AP, lateral, effective diameter, and so on. This is another paper reported the relation between the diameter and the body weight. This is the report from the APM. This is the effective diameter. How we calculate the effective diameter? The effective diameter is we calculate like this. The first we should get the diameter in the lateral direction, and then we should get the diameter in the AP direction, and then we multiply like this, and then we get the effective diameter. Basically, it's very easy. However, if we have a patient with many slices, maybe more than 100 slices, this effort will be very time consuming. Therefore, the special software will be very useful to get the diameter, effective diameter. This is the research from the to investigate which is the better, using localizer or axial images. In this report, suggests that the using axial images is better, is more accurate than using localizer or SPR or scanogram, because the localizer is tend to magnification or minification if the position, if the patient is not properly positioned in the center of the country. This is the and where we should calculate or measure the effective diameter, lateral diameter, and also AP diameter. Actually, we can measure from the center of the patient, or we can also measure from the maximum in the position, give the maximum diameter like this. Also very interesting. Okay, as we mentioned before, that the geometrical diameter is not very accurate to estimate the patient, because the CT dose not only depend on the size of the patient, but also depend of the composition of the patient. Therefore, another metric is introduced, namely water equivalent diameter, TW. And this is the equation to calculate the water equivalent diameter. To calculate the water equivalent diameter, we should use software, although very simple software, because we should calculate the average of city number in our region of interest. This is our region of interest, circular ROI, region of interest, and then we calculate the average pixel number within the ROI, and then we also calculate the area within the ROI. if we get the average value of the pixel value, and we have a area of the ROI, and then we calculate using this equation, and then we get the water equivalent diameter. Actually, this is not very easy to do if we do not use specific software to calculate the water equivalent diameter. However, this diameter is more accurate than previous diameter. And this is the automated technique to measure the water equivalent diameter. And this is my proposal, and it has been published in the JSCMP, the journal published by the AAPM. The algorithm is like this. This is the original image, and then we do threshold process. The limit of the threshold is about minus 300 Hounsfield unit. It means that every pixel value lower than minus 300 will be zero, will be black, and the pixel value more than minus 300 Hounsfield unit will be white, like this. However, we can see here that there are many holes within the patient, and to overcome this, we use edge detection like this, and then we do labeling in every holes, and then we measure every object within the patient, and the edge of the patient considered as the widest object, like this. This is the widest object, and this is considered as the border of the patient, and we can get the border of the patient accurately and fastly, like this. And this process will be done very fast using IndoseCT, and I think we will use IndoseCT together after this explanation. This is another examination. This is using the ROI fitted to the patient and compare to the ROI circular region of interest. This is mine, and this is come from the AAPM. And this is the relationship between the water equivalent diameter and the lung dose. It is very interesting. Actually, the implementation of the CT, there are two types. Using fixed tube current, this is the old technology, and the new technology using tube current modulation. It means that the tube current in the CT is not fixed during the acquisition time, but the tube current is modulated, is changed, follow the contour of the patient, like this. If we use the TCM, the dose will be decreased with the decreasing of the diameter of the patient, like this. This is using TCM. However, for the old technology, without TCM, this is the conventional technology of CT, the dose will be higher if the diameter is smaller, like this. This is the last I will present about the organ dose. It is very challenging to estimate organ dose in the CT accurately. Basically, to estimate the organ dose, many researchers in the world using Monte Carlo simulation. such as using PHITS or using MCNP or using PIM NRC or using EGS and so on. And after implementation of the Monte Carlo simulation, and then we plot the dose we receive. The x-axis is the patient diameter, and the y-axis is the dose. And if we use the fixed tube current, the dose will be decreased exponentially with the increasing of patient diameter like this. This graph like this is published many times in the scientific journal like this. This is the new approach how to measure the dose of the organ directly from the image of the patient. If we want to measure the dose to the patient, the organ dose of the patient, we should get the dose distribution within the patient. As we mentioned before, that the dose of the patient is not homogeneous. It's not homogeneous. If the patient is very small, this is a very small patient, or using head phantom with diameter of 16 centimeter, the dose is relatively homogeneous. However, if the diameter of the patient is larger, for example, for the body, the dose is not homogeneous. The dose will be larger in the peripheral area and will be lower in the central area. So if we want to obtain the organ dose within patient, we should have this distribution. This is very important to get the directly estimation of the organ dose. And this is the equation we found from our for our examination, for our research like this. The SSDE proposed by the AAPM is only for the average dose of the patient with various diameter. However, the AAPM doesn't consider the distribution within patient, and this is the equation to get the distribution within the patient. And we use the phantom. This is the handmade phantom. We made from the 8 centimeter up to 40 centimeter. And then we measure the dose from every holes within the phantoms. And we like this. For the diameter more than 32 centimeter, the dose relatively homogeneous. However, if the diameter is lower, the dose between the center and the peripheral is not longer homogeneous. And then we calculate the size conversion factor based on the position and the diameter, and we get like this. I think this is the more important to estimate the dose in the center and also the dose in the central and the peripheral areas like this. This is the methodology how to estimate the dose, the organ dose in every patient. The first one, we should measure the DW, water equivalent diameter, like this. And then we calculate SSDE, as mentioned before. And then we calculate the SSDE-C using the previous equation. And then we also calculate the SSDE in peripheral position, like this. And then if we want to measure the dose of organ like this, we determine the center of the organ, and then we measure the position compared to the center position, and then we calculate this one by using interpolation between the SSDE-C and SSDE-P, peripheral, and we get the dose in this pixel. This is the methodology to measure the dose in every pixel. Fortunately, in the IndoseCT, we can measure in the all pixel within patient, and very fastly. We will do together after this. Okay. The important thing also, if we want to measure the dose of the organ, we know that the diameter of the patient is variable along the z-axis, along the z-axis. Therefore, if we want to more accurate estimate the dose of the patient of the organ located in the specific location, we should use the water equivalent local water equivalent diameter, not using global water equivalent diameter. If we want to measure the dose to the eye, for example, we should only measure the water equivalent diameter in the eye only, not for the all position, like this. And then we will get the more accurate dose estimation of the eye, like this. This is the example. This is the example we already published in the Journal of Biomedical Physics recently. Yeah. This is the dose. This is the patient, from one patient to the 14th patient, and this is from the TLD measurement, and this is the estimation using SSDE. This is the closer to the TLD measurement. This is using the local water equivalent diameter. The result is fairly close to the measurement. Okay, I think the dosimetry is like that, and the next we will move to the IndoseCT. However, before we move to IndoseCT, maybe the participant have. Okay, okay. Please, if you have any question, please tell me, and then we will move together to download and to use IndoseCT together. Mr. Fajar. Mr. Fajar. Hello, Mr. Fajar.
Hello, hello.
Okay.
Thank you very much, Mr. Dr. Hairul Anam, for giving such an informative and interesting presentation. Very, very nice presentation. Ladies and gentlemen, now the time for the question and answer session. I would like to have 3 or more questions from the participants, please. Maybe any.
There are already questions in the chat room.
Oh, okay. Thank you. Mr. Dr. Hairul Anam, there is one question For Mr. Adiwasono in chat box, if we want to calculate the dose along the scan coverage, do we must multiply the dose organ that we already measure with this software? I mean, if the renal is about 10 centimeter long, how we calculate dose in renal?
Okay, thank you very much from the question. I think using IndoseCT is very simple to calculate the dose of to the renal organ. Maybe in the next session we will do together how to measure the organ, specific organ such as renal or other organs. It's very simple. However, the IndoseCT for the contouring of the organ is up to now is manually contour. Maybe in the next version we will develop the automated method to automatically contour every organ. This is very nice, and I think we will do together in the next session.
Okay, thank you. Maybe any question or response from Mr. Adiwasono? Hello, Mr. Adiwasono. Maybe you can give some response for the question from speaker, Mr. Dr. Hairul Anam.
Okay, maybe we move to the downloading and installing IndoseCT.
Okay. I'm sorry, Mr. Anam.
Yeah.
There is the question from Mr. Evan Lubis.
Yeah.
Okay. He said that, thank you, Dr. Anam. This is very interesting indeed. I have one question. How do we address the difference in electron densities during organ dose calculation? Is it included in the conversion factor?
Yeah, thank you, Dr. Evan. It's very interesting. However, the IndoseCT is not already address this issue. Maybe in the next we will. I think we can do research together to deal these issues in the next. I think up to now this issue is not addressed. In the calculation of the organ dose, we only use dose distribution, considering the every organ is with the same composition.
Thank you, Mr. Anam. Maybe any response from Mr. Evan? Oh, okay. I see. Anyway, this is good work. Looking forward to working your team. Okay. Maybe any question again from the participant? If there are no questions, maybe next step.
Okay. We move to IndoseCT.
Okay.
Can we move?
Okay, Mister. And the participant maybe can take computer maybe. Oh, the Mr. Samsun. There is question, Mr. Anam. Mr. Samsun said that, thank you, Dr. Anam, share for information. This question is, how does calculation scatter radiation?
Yeah, in the CTDI volume calculation, also in the SSDE calculation, we see in the big picture, we not see very detailed, such as similar for example, in the Monte Carlo simulation. In the Monte Carlo simulation, we see every detail, such as scatter and so on and so on. But if we want to calculate the CTDA volume, we want to calculate the SSDE, we only see the big picture without detail to the scatter radiation. It means that if we calculate the SSDE and we use the size conversion factor, actually the scatter is included in this size conversion factor. However, globally we do not see locally, and we do not see very detailed, but globally. But actually, the scatter radiation is included within a size conversion factor, like that.
Okay, thank you, Mr. Anam. Is there any question?
Thank you, Mr. Anam. Okay.
Thank you, Mr. Samsun. Maybe any question for the participant?
Can we move to the next session?
Okay, Mr. Anam, please.
Okay. We will move to the next session, how to download and installing the IndoseCT. And I hope all of you use another PC, yeah, other than for the Zoom meeting. Yeah. Okay. Okay. This is the IndoseCT. Wait a minute. Wait a minute. I should close first this IndoseCT. Okay. To calculate the CTDI, also water equivalent diameter and effective diameter, and also SSDE, including organ dose. Yeah. We can measure all of these things using IndoseCT. Okay. The first one, we should download the IndoseCT. Okay, to download the IndoseCT, the first we should enter to the IndoseCT website. Okay, please follow me. And if you any question or you want to slowly, yeah, please tell me if I speak not slowly. Okay, to enter to the IndoseCT, we should write the IndoseCT website, Indose, INDOSAECT.com, IndoseCT.com, and then enter. Okay, we have entered to the IndoseCT website like this. I'm sorry, this is disturbed me. Okay, this is the IndoseCT website, and then we can see the IndoseCT carefully. Yeah. This is the home. This is the description. This is the features, publication. So if you want to know more deeper about the IndoseCT, you can move to the publication like this. Publication like this, and every publication have a link. This is have a link to the publication if you want to know deeper about the scientific aspect of the IndoseCT. For example, If we click this one, for example, we will go to the paper published in the Atom Indonesia, evaluation of the effective diameter and its impact on the size specific dose estimate. Okay, I close again. Okay, I close again this one, and we back to the IndoseCT like this. Okay, this is the download. This is the news. If you want to know the news of IndoseCT, maybe this is the support. Maybe you have a question, or you have the idea. Please send to me your idea. Or if you see some problems, some errors in the IndoseCT, don't hesitate to tell me. Yeah. I will appreciate every information from all of you. Okay, we back to the home like this. With the home, we can move to the down. This is the manual book of IndoseCT in English or in Bahasa Indonesia. The size of the file of this manual book is about 13 megabyte. I think it's not so okay. In this, the developers, me, this is my student Fahmi, Dr. Freddy Haryanto. I think all of you already known these guys. This is Dr. Rena, Professor Idam Arif, and so on, Professor Jeff Dahalti. And if you have any question, also you can send to my email like this. Okay, the first one, to download the IndoseCT, we can press this button, download IndoseCT, or this one, download. Okay, I click this one, download IndoseCT. Before the downloading, you should fill this box, such as the name, maybe it's Khairul Anam. However, if you already have the file, do not do again. If you don't have, please do after me. This is name, Khairul Anam. Email, this is my email, for example. Any profession, maybe medical physicists or lecturers or researchers. Country, maybe from Indonesia or from Malaysia, yeah, or Japan. Institution, this is the example from the Diponegoro University, like this. And then the version, we can choose the 32-bit or 64-bit. This is depend on our computer architectures. However, for the modern computer, the most of them use the 44-bit like this. We choose this one. Okay, after we filling all the box, and then we click this one, download IndoseCT. Okay. Okay, this one, this is the in process of downloading IndoseCT. The file is about 130 megabyte. So if you this time of downloading depend on our internet connection. Now I am in campus with very fast network. This is about 60 megabyte, about the half of the all process. Okay, we wait together. We wait together. This 100. The rest is about 30 megabyte. Okay, this is already downloaded. Yeah, the file is already downloaded. Okay, and then we move to our this one and our downloads. This one, and this is the files. The file of IndoseCT, the IndoseCT setup. Yeah, dot v 20b dot 29 44-bit, yeah, like this. After that, because this file is WinRAR archive, we should extract this file. Extract here. Extract here. Okay. I have already the file, so I cancel this one. Okay, and this is the file for installing IndoseCT. Okay, have you already done this process?
Yes, already.
Yes,
Yes,
okay.
okay.
Okay, and then we move before we installing the software. Actually, I have the software. I will uninstall first. I will uninstall first and this software, and then we install together again. Okay, to uninstall. This is IndoseCT, and then we click this one and then uninstall. I uninstall first. Don't follow me because I have already installed the IndoseCT in my computer. This is IndoseCT, and then uninstall. Yeah. Okay. Yes. Yeah. This is the process of uninstalling of IndoseCT. Okay. Should move this one. Uninstall. Okay. Wait a minute. To uninstall this IndoseCT from my computers. Okay, completed. It's already uninstalled from my computer. Okay, I also delete this one, the shortcut from my computer. Delete. Okay, everything is gone from my computer. Okay. We back to the file of IndoseCT. This one, IndoseCT setup .v20b, like it. The size is about 131 megabyte. Yeah. Okay. Are you already have this file?
Yes, already. Yes,
Okay.
already, sir.
Yes, yes,
Okay,
already.
okay.
Ready
Okay,
already.
Thank you. Okay, and then we install this file. Please double click this file. Double click this file. Wait a minute. My computer is very busy because so many applications. Okay. Do you want to allow this application from unknown publisher to make changes to your device? Choose yes. And then we ask to enter the password.
Yeah.
The password is in this example, yeah. UNDIP undip 2021. Jadi undip 2021.
Once again.
Yeah. Undip. Okay. Maybe I will so this one. Please wait a minute. Sorry. This one. UNDIP 2021. This is a password. Okay, we pick again this one. Okay, and then press OK. Click OK. Wait a minute. Wait a minute, yeah. Because our computer is very busy, so many application is used. Okay, and then we have a welcome to IndoseCT setup, and then click next. Okay, and this choose install location. If we agree with the destination folder, and then click install. However, if you want to place in another folder, please check your computer. Okay, because I agree with this destination folder, and then I click install. Okay, this is the installing process. Maybe it takes I think it takes less than 5 minutes, but it's depend on our computers. Yeah, wait a minute. Good morning, Mr. Sani Umar from what is your country, Mr. Sani Umar? From Africa. Okay. Okay. The process is completed, and then if the process is completed, and then we press the next button. Okay, and then click finish. Okay, our IndoseCT is already installed in our computer. And we wait a minute. Okay, I think everything is okay. Okay, after installing, the IndoseCT is automatically opened like this. Have you get this IndoseCT?
Yes, sir. Yes.
Okay, thank you.
Yes, sir.
Okay.
Yes, sir.
Okay, okay. Okay. I hope all of you are success to installing the IndoseCT.
Of course.
I'm sorry, Mr. Anam.
Yeah.
There is information from Mrs. Irna.
Yeah.
He used the Mac operating system. Sister.
I'm sorry. Until now, the IndoseCT is only applicable for the Windows. Maybe in the next we will develop for the Mac system. I'm sorry for this.
Okay, thank you, Mr.
Okay, if you already get this IndoseCT, please close this IndoseCT, and then we will make a shortcut or another. I close this IndoseCT. Okay, this close IndoseCT. And now, how to open? How to open IndoseCT? To open IndoseCT, we can tap this start like this, start, and then we click this start like this, and then we choose the location of IndoseCT. We choose this one is IndoseCT. It's IndoseCT. We can click this file, this IndoseCT, and we click like this. Again, IndoseCT is open. Okay. Okay. I will close again, and then we will make a shortcut of IndoseCT in our desktop, in our monitor. So the opening of IndoseCT is faster. Okay, I close again. I close again like this. Okay, and then I will make the shortcut of IndoseCT in my screen. Okay. The first, I right click button, right click like this, and then we choose new, and then we move to the shortcut. It means that we make a new shortcut like this. This is the dialog for creating shortcut. Okay. After that, we should browse the location of the IndoseCT. We browse like this. The IndoseCT the default location is in the PC, and then local disk in my computer, in the C, and then in the program file, and in the city, this one, in the city. And then we search for the in the city. This one. This is the in the city. Yeah, in the city, and then we click in the city like this, and then we click OK. Okay. This is the C program file in the city Excel, and then we click next. Okay. The name, if we want to replace the name, it's depend on you. In this case, I click finish. The name of our desktop, our shortcut will be in the city. Okay, finish. Okay, I have a shortcut of IndoseCT. Okay, if you want to make our IndoseCT short by the name, yeah, we can short by the name, by the size. Yeah, it depends on us. Okay, like this. This is our IndoseCT, our IndoseCT. Okay. It's very simple to make shortcut of IndoseCT in our screen. Okay, Again, I will enter to the IndoseCT. This is the downloading and installing of IndoseCT. I think it's very easy to do these activities. Okay, I wait for the participant. I hope all of you are already get this IndoseCT. However, if maybe one of you is not already get this IndoseCT, please tell us what is the problem.
Okay, thank you, Mr. Anam. Maybe if all the participants, if any problems and want to share screen, please let me know.
Okay, it's okay. Apanya? Iya. Bentar. Yeah, I'm sorry. Okay. Any question for from participant? Mr. Fajar?
Okay.
Are you already installed this one?
Yes.
Are you success?
Yes.
Okay.
Yes.
Okay.
Yeah.
Okay. If you already success to install the IndoseCT in our own computers, and then we will see deeper the application of the IndoseCT. Okay, before we move to the to see deeper of IndoseCT, I will introduce the components of IndoseCT. This is the main screen. This is the logo of IndoseCT. This logo is designed by my student, Mas Arich. Thank you for this design. This is the button. This is for opening file, and this is for open folder. Maybe in some cases we want to open our image using folder, and this is the open sample. This sample is an image of phantom from Kyushu University. Thank you, Professor Fuji, for giving me images of the anthropomorphic phantoms. And this is to see the DICOM info. And this is for setting. And this is for downloading user manual. We can see the user manual from this button. There are two user manuals in English or in Bahasa. Yeah. For example, if we want to see the user manual in English, we click English like this, and then we get this one, the user manual in English. The pages is about 110. This is the user manual of IndoseCT in English. Please see this user manual carefully to understand the IndoseCT well. Okay, and then this button to save our record. If this button to see our database, after we calculate the patient dose, we can save the data and save in database. And this is windowing for the image. I think many windowing, but the windowing is disabled. The windowing is able, will be able after we open the image. And this is the data of the patient. And this is the main tabs of the IndoseCT. And this is the tab for calculating CDDI volume, to calculate diameter, to calculate the SSTE, to calculate the organ dose, and this one to analyze our data in database. So we can analyze without Excel software. But if we want to export our result to the Excel, it's support by the this IndoseCT. Okay, I think like that, and this is many option in the IndoseCT. Okay, the first one, we will move to open the image. Let's try together. Maybe I think not all of you have the images. In this case, we will try using the sample image. This is the image from the Kyushu University. Thank you very much, Professor Fuji. We open this sample. Yeah, this sample is open. This is open like this. We can move from one slice to another slice using this button. And this next slice. If we press 1, will be moved to a next slice. This is the slice number 2, slice number 3, slice number 4, slice number 5, slice number 6, slice number 7, and we can back using this button, previous slice, slice number 6, slice number 5, number 4, number 3, number 2, number 1, and if we press this one, will be go to the last slice. It will be 88, 88, 87, 86, 85, and so on. However, if we want to go to the specific slice, maybe it is important. Maybe in some cases, we open more than 1,000 slices maybe. In the modern CT scan, one patient have more than 1,000 slices. It's very much slices. We can using this button. For example, we will go to the slice number 50, for example, 50, and then we go to the slice like this. Okay, we go to the slice number 80, number 50. Okay. Okay. Any question? If not, okay, we move to move from one slice to another slice. We can also use the button in our keyboard using page up, page down, home, and end arrows. Yeah. To move to the next slice, we can press the button page up. Move 1, 51, 52, 53, 54, 55, and so on. And to back to the slice, to the previous slice, we press the page down using our keyboard. 55, 54, 53, 52, and so on. And then, and we can also using the arrow, right arrow or left arrow. If we use the right arrows, it will be moved to the slice number 5. Number 5 after the image in the screen. For example, this is 42, 42, 42. And if I press the right arrow and then go to the 57, I think. Yeah, 57. And then 62, and then 67, and so on. Similar, if we press the left arrow, the slice will be decreased 5 slices. This is 67, 62, 57, 52, and so on.
I'm sorry, sir.
Yeah.
This is question for Mr. Suryani.
Yeah.
How to open the sample, sir?
Just click this sample. Just click this open sample.
Maybe you can. Oh yes, yes.
Yeah. Just click open sample.
Okay, thank you, Mr. Anand.
And there is question for Mrs. Tuti.
Yeah.
Is there maximum slice for IndoseCT, sir?
No.
No. Oh,
No.
yeah.
It depends on our computer. If we only use very small memory, it will be problem. However, if we use a very high memory, it's no problem.
Oh. Then from Miss Vidya, can we get the picture sample?
Yeah. On the sample, please open this one.
Oh,
Open
yeah.
sample.
Open sample.
Okay. The next, I will show you how to open the image of the patient. If you, I'm sorry, every image from the specific CT machine sometimes different. So maybe the images from specific CT scanner can be opened using IndoseCT. I'm sorry for that. Yeah, yeah, we will do the best, but unfortunately, so many challenges to develop the software can hold all our CT machines. Yeah. Okay, I will show how to open the image. I will use open file. Open file. If we have the CT images, we can use open file. Open file. This is the example. I have Citra City and IndoseCT, and I will open this one from the CT sensation 64. Okay, I double click in, and then this is the files, and then I click one, and then I choose all image, all file. However, I will only open the axial images, so other images will be left behind. So I the dir file and other file. Okay, the file is already chosen, and then I open this images. Okay, yeah, this is the images of the patient.
Sorry, sir. How can we import image CT from another device, sir? For example, flash disk.
Yeah. If you have file, please copy. Please copy the file as usual. And locate in the specific folders. As usual.
Okay.
This is only an example. If you don't have images, just see.
Okay. There are so many questions, sir, in chat box.
Yeah.
Can we miss, sir, if you use another TV, not only 80 and 120 kilovolt? Sometimes we use 100 kilovolt.
Okay. I will explain later.
Oh, yes.
Please wait a moment.
Okay. Thank you, sir.
Yeah, we move step by step. Okay. This is a file. Now, sometimes file we open, sometimes it's not orderly position. If we want our image is short orderly, so we can click this short image. Short image is to make our image is short orderly. Maybe from the slice 1, slice 2, slice 3, etc. Because maybe the slices is not orderly. Maybe from the slice 1, move to the slice number 5, move to the slice number 15, for example, back again, etc. To make the slice is order, click short images. Okay, this is already shorted. Okay, and then our image ini can be moved, yeah, can be moved up and down using hold the left button, and then we move our cursor. This is we can be moved. We can also enlarge our image. Similar if you enlarge the image from our handphone. Yeah, we can enlarge. We can enlarge, we can minimize, we can maximize our image like this. We can move. Okay. And then we can also set our windows. This is the soft tissue windows. We can set another windows, for example, bone windows or lung windows or liver windows or fat windows. Also, we can custom. We can set by ourselves. For example, we set the window level, for example, 100, and window width, for example, 100. If we enter, this is the new window, our custom window. Okay, we pick again to the soft tissue window. Okay, for an example, we move again to the sample image. We move again to the sample. This is the sample image of the anthropomorphic phantom from Kyushu University. This one. Okay. We can maximize, we can minimize, we can move from one position to another. Okay. And then we will move to the main button of the IndoseCT. Oh yeah, Moh Saat Baruki, raise hand. Any question? Please, if you have any question.
Yes, I have a question for you.
Yeah, please.
Can you listen my voice?
Yes.
Yes, yes.
Bismillah. It's like this. We have already know that the picture must be in DICOM format.
Yes.
But
right. Yeah.
In field, if we have no key legal password to extract the images into DICOM, because there are some CT scan can't extract into DICOM. Can we change or replace or make it with JPG or PDF format, sir?
Okay, thank you for the question.
Yeah.
I'm sorry.
I mean, it's like this. Okay, we have got this applications like it's so useful, I think. But if we have the devices or application, but we have no data because we can't extract that image to DICOM. So I mean, it will be useless, I think. But
okay.
Please.
Okay. Okay. Thank you very much. Thank you very much,
Okay.
Mr. Moh Saat.
Yes, sir.
Unfortunately, the images supported by this IndoseCT is only in DICOM format. Unfortunately, maybe in the next we will develop another format, but it will be difficult because to calculate the dose, we need many data from the DICOM info. That's the problem. But we can also calculate the SSDE or CDDI volume without image. It can be, but if we use the image, it should be used in DICOM format like that. Maybe in the next we will develop another format. Thank you very much.
Okay, thank you.
Okay, and then we move to our main dose calculation. There are many types here: CDDA volume, diameter, SSDE, organ dose, and analyze. The first one, SSDE. For the calculation of SSDE, to get the SSDE, there are three options. Calculation, get from DICOM, and input manually. Three options. Calculation, get from DICOM, and input manually. If we have the CDDA values, for example, from measurement or from CT console, we can input the CDDA volume directly. For example, this is 10 milligray, for example, manually, and the LP, for example, 100. For example, it can be from CT console, or it can be from measurement using phantoms and pencil chambers. And this is, and then click input like this, and then we can move to calculate diameter. This is the very standard. This IndoseCT is such kind of calculator. And then we move to diameter. And this is the many option: effective diameter and water equivalent diameter. We only choose one. The first one, I will choose the effective diameter. Choose effective diameter like this. And then the source. It can be from image or it can be input manually. In this stage, I will input manually. So input manually like this. Now, if we choose input manually, there are options here. This is consider if we have the diameter, whether effective diameter, AP diameter, lateral diameter, sum of the two diameters or H like this. Okay, for example, we have already the effective diameter, for example, like this. Maybe this is just for example, maybe 10 centimeter. Okay, 10 centimeter. And then we calculate. Yeah, because we input 10, the output, of course, 10 also, 10 centimeter. Okay, it's okay. Yeah, so we have already the value of CDDA volume. We have already the value of diameter, 10 centimeter. And then we can calculate the SSDE. We can calculate SSDE. This is an example calculation of SSDE without image. Okay. And then after we input the CDDA volume, input the diameter, and then we calculate SSDE. Please mind that CDDA volume is based on the phantom. What phantom is used? Body phantom or head phantom? It should correctly chosen. For example, in this example, we use body phantom with 32 centimeters in diameter. Okay, if everything is already set, and then we calculate. If we want to show the graph, we can tick this one, and then we press calculate. Okay, we get our values of SSDA. We get here the CDDA volume is 10 milligray. Diameter effective is 10 milligray centimeter. Conversion factors based on the 10 millimeters diameter is 2.57 like this. Yeah, this is the graph. This is the x-axis is diameter effective. Y-axis is conversion factor. Diameter effective 10 centimeter. The conversion factor will be 2.57 like this. And then we automatically obtain the SSDE. The SSDE will be 25 milligray. We can see here that the dose in the terms of SSDE is more than twice compared to the CDDA volume like this. Yeah, CDDA volume is dose output of the CT machine, and dose to the patient is 25 milligray. This is the very simple. We will try another phantom. Please see carefully. If I change this phantom from body to head, for example, I will change from body to the head, from the head. And then I calculate again. The first is before is 25. After we choose to the head, the number will be changed. Please see carefully. I will click calculate. Yeah, calculate this change to 12. Before is 25. Now is 12. So the calculation of the SSDE is strongly depend on the phantom we use. So please carefully to consider this type of phantom like that. This is the very simple technique to calculate the SSDE. Okay, we back again. This is the CTDA file, and then we will see deeper every tabs. Okay, we will see deeper. Okay, we back to the CTDA volume, CTDA file. As I already mentioned, there are three options of the CTDA volume. Input manually, as already done, calculation, and get from DICOM. And now I will use calculation like this, calculation. If you already use those calculator, such as Impact City or Wazaari from Japan, or using City Expo from Germany, I think. Yeah, this like that. This IndoseCT like this. Yeah. If you use calculation, there are input parameters, and this is the output. At least to calculate the CTDA volume using the database, at least we should use 8 parameters. We should know the manufacturer, just like Siemens, Toshiba, GE, Philips. I'm sorry, our database is very limited. So if you have data, please send to us. Please send us. We will integrate your data to this IndoseCT. Siemens, for example, we choose Siemens. We choose Siemens, and then scanner. For example, we choose sensation 19, for example. And then we should choose this one, voltage. For example, this is the available voltage for the sensation 18, 80, 100, 120, 140. For example, 20, for example, like this. And then we should fill the tube current. And this example is 100. We can also change this value to 200, for example. And then rotation time, it means the Gendry rotation time. This is the 1 second. We can choose, for example, 0.9, for example. This is pitch. Please refer to the book to understand what is the pitch. Yeah, pitch. We can, for example, we change to the 2, for example. And this is a collimation beam collimation. In the Siemens sensation 16, there are many beam collimation. For example, we choose 10 millimeters. And this is scan length to calculate the DLP. Yeah. If all parameters are already set, already set, and then we press calculate, and then we get the MAS 180 milliampere second, and then effective mass is 15, CDDAW 29, CDDA vol 2.49, and DLP 24.9. Now these values depend on the parameters. For example, I will choose one by one. For example, I will change the scan length from 10 to 20 centimeters. So the output will be changed, but only for the DLP. If we change this to 20, this will be changed, multiplied by 2. I calculate this one, 49. If we change the voltage also like that. For example, I change from 120 to 140. 40. Oh, there is no head revolve on this voltage. Okay, because this is head, yeah, we can change to the body, I think. Yeah, this values is on also depend on the phantom we use. Please remind that our values depend on our phantom use. Okay. Okay. I will change from 10, for example, to 24 or 18, and I calculate again. Yeah, and the values is changed. Okay, like that. Yeah, this is similar to the Waza-Ari or Impact City or City Expo or other calculators. Okay. But yeah, this IndoseCT, this parameter can also input without manual input, but using get info. Using get info, we will enter the parameters automatically. But this effort not always successful, because the DICOM info in every image may be different, maybe not available. For example, I will get the info from the DICOM info from this image of the anthropomorphic phantom. I will press this get info. Okay, the total collimation width is not available. Okay, the Alexion City from Toshiba installed at Kyushu University is already in our database. Alexion is already. However, the collimation is not already in the DICOM info. This is the problem. So we should input manually the collimation. For example, we set 16 like this. And then we have already information of the input parameters for the Toshiba election. And then we calculate like this. And this is the one step, more than other software such as Wazari or City Expo. Okay. Is there any question?
Yes.
May I, Mr. Anam?
Yeah, please.
Sorry, just for make sure, you said that collimation, for example, 60. If we use 14 detector active, or maybe 64 detector active, and we use the beam collimation is on Philips 0.625. So we use the collimation is the measure crossing from detector active and beam collimation. Is it right? So
yeah.
if we use 40 detector active with the beam collimation is 0.625, so we use beam collimation. We use collimation 25. Sorry.
Yeah,
is
yeah.
it like that?
Yeah. Beam collimation is depend on the setting in the CT scan we use. We do not consider about the specific case, for example, overbeaming. We not consider that. We all only get these values from the DICOM info. Oh yeah, I forget. To see the more detail about the DICOM info, we can see from here, from here, the DICOM info in the top of the image, DICOM info. We can see detail of the DICOM info. Okay, we can see together. For example, this is the acquisition date, study time, modality, city, manufacturer, Toshiba, institution name, Kyushu University, series description, axial, 7, manufacturer model, Alexion, the patient ID, patient sex, this is empty, patient birth date, empty, because this is phantom. Key slice thickness is 7 millimeters. Key VP 120 kilovoltage. Data collection diameter 430, like this. Reconstruction diameter about 40 centimeters. Can retail 0. Table height 100 millimeters. Exposure time 1000.
Hello? Hello, sir?
Yes, I'm sorry.
Oh.
Our connection is break.
Oh, yes, never
Yeah,
mind.
problem in our connection.
Yes, yes.
Okay, we back again. Okay, this is you can see the DICOM info in this so many information in DICOM info. If we want to measure the diameter of patient, we should know this information. Therefore, we cannot calculate the diameter of patient without DICOM info. The calculation is based on this data. Okay. We move again. This is a calculation. The very convenient way to calculate the SSDA, the CDDA volume is from DICOM. However, not all DICOM info contain these values. This is for note. Not all DICOM info contain the contain the CDDA volume. Fortunately, our sample from Kyushu University contain the CDDA volume. So, if the image contain the CDDA volume, we can extract directly from the image. For example, if this example, this is the CDDA volume, we can click calculate. If we click calculate, yeah, we get our values. The scan length 88 millimeters, CDDA volume 6, and then DLP is about 100 milligray centimeter. And this is the most convenient way using the DICOM info. But I repeat again, not all DICOM info contain this value. Okay. This is how to calculate the CDDI volume. Okay. Is there any question before we move to the diameter?
Yes, sir. Hello.
Yeah.
Okay. From Mr. Adiwasono, is it possible right now any features to connect IndoseCT direct to modality or PHITS so we can get image easily?
Yeah. Inshallah, we will move to that features. Yeah. Please help me.
Okay.
Yeah,
And
I'm very happy if all of you help me to connect the IndoseCT to the PACS system in the hospital.
Okay. And from Mr. Hantoro, how thick each slice was?
Slice thickness is depend on the CT technology. In the previous technology, the slice thickness is about maybe 5 millimeters to 10 millimeters. However, the recent technologies, after the introduction of multi-slice CT, the slice thickness is become smaller and smaller. And now, the slice thickness is less than 1 millimeters. Yeah, so the resolution in the Z-axis is very nice now.
Okay, sir. And then from Mr. Gomgom, sometimes operator rename a patient name on console, so those record and those report lost. Do still IndoseCT application can get information using feature get from DICOM if we only copy slash image DICOM from machine?
Yeah, this IndoseCT is automatically get the information of patient, and then the information is displayed in this IndoseCT. However, in this workshop, I should erase the name of the patient for ethical reason.
Okay, thank you, sir. And from Mrs. Sania, is IndoseCT able to be used for the public open source? So we can publish some research using the software, or do we have to apply for the licenses first?
No, yeah,
Okay.
please use the IndoseCT and publish anywhere.
Okay. Okay, sir.
Yeah.
And by the way, some of participants don't have file input, sir. Maybe.
Yeah. Use this one. Use this one for
sample.
For using open sample.
Oh yes. Yeah.
Yeah. After we mastering the software, and then we can go to the hospital using the real image from the patient.
Okay.
Okay.
Thank you, sir.
Yeah.
Maybe any question?
No? Okay, we move to the
and from Mr. Andin,
yeah.
Can we measure if we use another kilowatt? Not only
yeah. The kilo voltage is set by the vendors, by the manufacturer. And this, if we choose using calculation, and this is based on the vendor. So we can choose another set. For example, this is not available 110, for example. So we cannot set 110. We only use this kilovoltage based on the vendor. And every manufacturer set their voltage differently. For example, Toshiba Alexion have a 4 option, 40, 100, 120, and 135. However, another manufacturer, for example, Philips, and then Brilliance 44, the manufacturer set different values. Only 3 values of the kilovoltage, 80, 120, and 140, like this. These values is depend on the manufacturers.
Okay. Thank you, sir.
Is there any question?
Maybe any question for the participant? Oh,
no,
yes. From Mr. Nugraha.
Yes.
Can the data that's open in the city not same? Some data hide than PHITS.
I don't understand.
On chat box, sir.
Can DICOM data that's open in the city not same? I don't know, but I guess now in the city it's not embedded, it's not the PAC system may be closed and cannot correlate with IndoseCT. I hope in the next IndoseCT can be correlated with the PACs, so we can measure the dose of the patient using copy image one by one. This is the limitation of IndoseCT. So to calculate the dose of patient using IndoseCT, now we should copy the image and then we move to our computers and then we measure. The IndoseCT have not already connected with the PAC system. We hope in the next we can do that with your help. So if you help us, it's very pleased to us.
Okay. Okay, thank you, sir. From Mrs. Christian, I'm sorry, or maybe Mr. Do the three calculation methods have the same result for one data?
Okay, because the three method come from different method, maybe the result is different. Maybe, but maybe in other cases the result is similar. For example, I will practice for this question. I will open one image of patient. Okay, in the city, I will sensation 44. Okay. Okay, let's see carefully together. So justify, is it same or not? The calculation of CDA volume from different method. Okay, this is from calculation. The Siemens sensation 44. I will get from info for the fast input parameters filling. Okay, Siemens sensation 44, voltage 120, tube current 178, rotation time 0.5, pitch 1.4, collimation 28.8, scan length 11. And then we calculate. We get the CDA volume 4.13. This is from calculation based on database. And then we will take these values from DICOM. Is it similar or different? Okay, we see together. Please note this 4.13. 4.13. Okay, and then we go to from DICOM. From DICOM, and then we calculate. The result is 4.29. It's a little bit different. Different about 0.1. Yeah. 0.1 milligray. Yeah, I think the difference is acceptable. But I don't grant these values. Maybe in the same cases, the difference may be very high. I don't know. So we should investigate these values. Actually, I will say this calculation data, the database is come from part of them come from Waza-Ari. I very thanks to the Waza-Ari. And then the part of them come from Impact City. Thanks to the Professor Edisu. Yeah. So this database is come from the two software. Therefore, because our database is very limited and it's very small database, I hope if you have a database from any scanner, please send to me. So please send to us. Our email is already available in website of IndoseCT, anam@fisika.fsm.undip.ac.id. Yeah, your help will be improve the IndoseCT in the future. Okay.
Thank you, sir. From Mr. Muharram, if there is an additional type of CT scan on a certain brand, how do I add it?
Oh, please send to us the data.
Oh, yeah.
Yeah.
Okay.
I will integrate your data to this IndoseCT.
Okay, sir. Thank you. And from Mrs. Anjani, several times patient data is lost then auto replace if saved in the same folder. This is tips from me to periodically saving in a new folder. But do not it just my PC, or do you have any same problem with me false? Thank you.
I'm sorry.
In chat box, sir.
In chat box, sometimes when some data is lost.
Yes.
Auto if save in the same folder. This is tip from me to periodically saving in a new folder. But my PC. I don't know. Yeah, and this is the problem, and why the IndoseCT is come. Yeah, because saving the image is need very high, very high space. This is the problem. I can understand that. So maybe periodically in some hospital, they erase the patient data. This is the problem. Therefore, the IndoseCT is come. This is come. IndoseCT will be maybe overcome that problem. Before the image is erased, we calculate first, and then we save the data. So it's no problem if we save the data. And in the city, the save very small data, only the very specific data. So the saving of the data is not need a very high space. Yeah, I understand that. Yeah, because the capacity of the storage is limited. Yeah, like that. Okay, thank you.
Thank you, sir.
Can we move to the another?
There is once again, sir, from Mr.
Okay,
Adin.
one again.
Okay, Dr. Anam, this is calculation for CTDI only one slice. Can we measure the value of CTDI for combination slice at one organ such as thyroid gland?
Yeah, actually, the IndoseCT can measure the CTDI not only one slice. I will explain later, but I will explain here. As I already mentioned, in the CT scan, some CT scan apply the TCM, tube current modulation. In the TCM technique, the tube current is changed every slice, but in the fixed tube current, the tube current is already constant every slice. I will show you that the tube current is constant in the fixed tube current and change it in the tube current modulation. Okay, I will show you in the using the sample image from Kyushu University. Kyushu University like this. Okay, we move to the from DICOM. Yeah, from the DICOM. In this slice, we can calculate the CTDA eval, calculate like this. The value is 6. The question is, can we measure the CTDA eval? I'm sorry, my connection is not stable. Okay, we back again. We back again. Okay. Can you see my my screen?
Yes, sir.
Yes.
Okay.
Yes, sir.
Okay. We can choose this one, Z-axis. Z-axis. We can choose this one. And after this, there are three options again. Three further options. Slice step, slice number, and regional. Slice step, it means that we can choose the slice step. For example, 1 or 2 or 3. If we choose the slice step is 1, it means that we calculate the values at every slices. If we choose 2, slice step 2, it means that we calculate the slice number 1, move to number 3, move to number 5, move to number 7, and so on. If we change to the 3, for example, then we calculate the slice number 1. After that, slice number 4, slice number 7, slice number 10, and so on. This is the slice step. The slice step. Slice number. The slice number, we can also set the slice number, and we can set here. For example, if we set the slice number is 1, for example, 1, it means that only one slice we will calculate. The one slice from the middle slice from the z-axis. For example, if we set 3, for example, if we set 3, slice number 3, it means that from the all slices, we only select 3 slices. 1 in the middle, 1 in the middle right, 1 in the middle left, like this. And regional, we can set the start slice to the end slice. We can set like this. For example, I will set slice step by 1. Slice step 1. It means that all slices will be calculated. And this is we can show the CTDA vol, and we can also show the MA, milliampere meter, milliampere. We choose this one, we take this one, and then we calculate. We get this graph. We can see here, the tube current is constant for every slices. As consequence, the CTDA volume is also constant. Why? Because the CT machine is apply not TCM, apply non-TCM technique. Yeah, it means apply fixed tube current. I will show you another example from the hospital. Another example. Wait a minute. See this one. Now this is from the hospital. Okay, we can see together, and then we will set the slice step is 1. CTDA vol show MA, and then we calculate. We get like this. This is a tube current, and this is a CDDA volume. This is the very strange data. Why? This is because the slice is not orderly. So before we calculate, it is better to sort the image first. Sort image. Click sort image, and then we calculate this one. Okay, we can get this one. Get this one. Yeah, this is tube current. This is tube current for every slice. We can see here that the slice, that the MA tube current is not constant, but this tube current is changes based on the contour of the patient. As consequence, the CDDA wall also fluctuation following the MA, the tube current. This is the example. So using IndoseCT, we can set these parameters. Interestingly, this is very important to note. Every CT scan have different way to save and to show the MA. In the Siemens sensation 44, the CDDA volume fluctuation depend on the MA, depend on the tube current. But in another CT machine, in another another CT machine, the CDDA volume maybe not follow the MA. This is the problem. I will show you another example. I will no. I will show you another example. This is from the this one, Aquilion, Toshiba Aquilion. I will show you from the Toshiba Aquilion. Very 400 slices. Okay. Now this is from the Toshiba Aquilion. From the Toshiba Aquilion. Okay, we can see together. Okay, we move. I will calculate the CDDA volume and MA of the Toshiba Aquilion for every slice. We can see together what happened. Yeah, this is the result. This is the result. We can see here the tube current is modulated. It means it changes following the contour of the patient. This is the tube current. However, the CDDA volume is constant. It's very strange. This is the problem. So in the IndoseCT, we add another feature, adjust CDDA volume with MA. This is another feature in the new IndoseCT, this version. In the previous version, this feature is not available. Adjust CDDA volume with MA. If we choose this one, we tap this one, and we calculate again. Okay, and then we get the different CDDA volume graph. Now the CDDA volume is follow the tube current. This is so if we see the DICOM info, we should see carefully because every DICOM is different. Okay, like that. Yeah. Okay. I think about the CDDA file is enough. We should move to another step.
Okay, sir.
Or maybe we take a rest, maybe 10 minutes.
Okay.
Okay, yeah,
Okay.
okay. We will
Okay.
back again, 10 minutes. Yeah, yeah, okay. I will go to the toilet first.
Okay. Ladies and gentlemen, we take rest about 10 minutes. Sorry, sir. Maybe can stop share screen.
Oh yes, yes. Okay.
Okay.
Okay, okay. Wait a minute. Wait a minute.
Okay.
Yeah. Okay.
Okay. Thank you, sir.
Bengawan Solo, riwayatmu indah sedari dulu jadi perhatian insani. Spojrzał Allah w to, a gdy nie ujrzał dna, wnet popatrzył w twarz księżyca i podniósł w górę dłoń i wstąpił w czarne fale i wstąpił w parnej nocy snem mgły, a gdy zanurzył stopy palec, tam rosły brzegi wysp i tu pora riwayatnya dulu
Bengawan Solo， 永远不改模样，只有痴情人，他不再唯一在我身旁。
Bengawan Solo, riwayatmu ini sedari dulu jadi perhatian insani.
Musim kemarau terserah airmu, di musim hujan air meluap sampai jauh.
Mata airmu dari Solo terkurung gunung seribu, air mengalir sampai jauh, akhirnya ke laut.
Itu padamu riwayatmu dulu.
Kaum pedagang selalu naik itu perahu. Mata airmu dari Solo terkurung gunung seribu, air mengalir sampai jauh, akhirnya ke laut.
Itu padaku riwayatmu dulu.
Kaum pedagang selalu naik itu perahu. Kaum pedagang selalu naik itu perahu.
No. Bengawan Solo 흐르는 강물은 언제나 변함없이 따스하게 늘 지켜주. 메마른 가뭄에 속 타던 날들이 시원한 비 찾아와 멀리 넘쳐 흐르네.
Okay, thank you, ladies and gentlemen. seen Mr. Dr. Khairul Anam, please.
Thank you, Mr. Fajar. We will continue again our workshop. Okay. I will. Okay. Can you see my screen?
Yes.
Okay. Okay. We will move to another types of IndoseCT, namely diameter. This diameter is steps to calculate the diameter of patient. To calculate diameter, there are two options. The first one is effective diameter, and then water equivalent diameter. We can only choose one. We can choose both of them. It cannot. We can in the first time we will elaborate the effective diameter. Then we choose effective diameter. Okay. After we choose effective diameter, there is option again. We can fill the diameter, input manually or from image. Input manually is already mentioned before. We can input the effective diameter manually, and there are 5 options here. Effective diameter, AP, lateral, AP plus lateral, and H. I will try using AP, for example. If we use AP, maybe, for example, we fill 15, for example, 15 centimeter, and then we calculate, then we get the effective diameter is 1830. And we can also show the graph. We take this one and we calculate again. This is the graph. The graph, the x-axis is AP and the y-axis is effective diameter. The AP is 15 and effective diameter is 18, like this. Maybe in some cases, we only have the lateral diameter. We can also fill this lateral diameter, for example, 15. We calculate again, and we can get this one. The lateral diameter 15, the effective diameter will be 13, like this. Or maybe we have 2 diameters, AP and lateral. If we have 2 diameters, we choose this one. Just this one, and then we fill this box, for example, in the AP direction 15, and the lateral diameter, for example, 19. And then we calculate again. Okay, and then we get this one. The AP plus lateral 32 centimeters, and the effective diameter will be 15.7 centimeter. And also, we can choose based on the age of the patient, like this. However, this age is limited from 0 years. The maximum is 18 years. This is especially designed for the pediatric patient. For example, if we fill this one, maybe 1 year and 4 months, for example, and then we calculate, and then we get this graph. The age will be 1.33 years, and effective diameters will be 19.88 centimeters. It should be noted that the age patient is based on the American patient. This may be not applicable for the Asian patient from the Japan or for the Indonesian patient. Therefore, we encourage for the Indonesian scientists, all of us, to work together to supply just like this data. Okay, like this. Okay, this is the way to measure the effective diameter using the age of the patient. And this is from the manual calculation. However, maybe in some cases, we don't have this type of data. We only have the image of the patient. Therefore, the effective diameter can be measured from the image of patient. To do that, we should choose this one, source. The source will be changed from input manually to get from the DICOM, like this. To measure effective diameter from DICOM, we should open the image. For this example, we will use image from the Kyushu University using open sample. Okay, this is the image of the patient. Okay, for example, we will measure the effective diameter from the head image. This is the slide number 8. Slide number 8. Okay, the image have been opened, and then the source get from image will be have been set, and then the method. There are 3 methods: automatic, auto z-axis. This is calculate for the z-axis as already mentioned, and manual. The first one, we will try the manual calculation of the effective diameter. If we want to calculate manually, then we take this one, manual. Okay. After we choose this manual, and then we have 2 options, AP and lateral. So we should draw the line in AP direction and lateral direction. Okay. To make the draw in the AP direction, we click this AP. Okay, and then we have a line like this, and then we set carefully this line. Yeah, we should locate this line in the border of the patient, in the top and in the bottom, like this. Okay, we move carefully. Okay, okay, and then we get the AP automatically, manually. The AP is about 18.81 centimeter. And then to measure the lateral direction, we click this lateral like this, and then again we move carefully to the border of the patient in the lateral direction like this. Okay, already finished. And then we get the AP, and we have the lateral, and we automatically get these values, 16.53, like this. This is the manual, very simple, very simple. But if we have so many slices, although this technique is very simple, it will be very time consuming. Gitu. Okay, if we will work again, we will try again, we click clear, and we can repeat again like that. This is the effective diameter calculated manually from the image. It is more convenient if we calculate the effective diameter using auto technique. If we choose this auto technique, there will be 3 options based on area, center, or maximum. The area means that we calculate the effective diameter is based on the area of the patient, like this. Okay, to do that, we only tap this button, and then we will get the effective diameter based on the area, like this. This automatically, the IndoseCT will automatically contour the patient, and then calculate the area of the patient, and then
I'm sorry, ladies and gentlemen, maybe Dr. Anam, there some trouble.
I'm sorry, the network is
Unstable.
unstable.
Okay.
Okay, we move again. If we calculate the center like this, please wait a moment. Wait a moment. If we choose the center, it means that the AP and lateral diameter will pass through the center of the patient.
I'm sorry, sir.
Yeah.
Would you like to share screen?
Oh yeah. I'm sorry. Share screen. Okay.
Yes. Okay.
Okay. We continue again. If we select the center, it means that the AP diameter and lateral diameter will pass through the center of the image of the patient. Okay, and then we get the AP diameter, and then we get lateral diameter, and we also get the effective diameter. We can calculate automatically. Yeah, this is the example. This is the center of the patient, of the image of the patient, and then we get the lateral diameter, and we get the AP diameter through the center, like this. This is the AP lateral, and this is the effective diameter. And then we can also choose the maximum. The maximum means that we calculate the diameter AP and lateral through the position, which give the maximum values of AP and lateral. Okay, for example, if we want to calculate, we choose this one maximum, and then we calculate this one. Okay, this is not at the center of patient, but this point is located where the AP diameter and a lateral diameter will give the maximum values. And then we will have the AP 19, lateral 14, and then the effective diameter, the 16. However, this three option is not is only very small differences. Actually, we can in some papers they use center, and in other some papers they use maximum. So this is the option for us to choose one of them. Actually, if we choose the effective diameter, this diameter is not considered the attenuation of the patient. If we want to get the more accurate dose, the diameter should consider the attenuation of the patient. For example, the bone will be more absorbed to the X-ray, and the lung will be less absorbed to the dose of the patient. So if we choose the center and max, we can also make a correction. This correction is based on the paper written by the Greek scientist Mihailidis, and you can read his paper in the British Journal of Radiology. This is correction. We can add the lung correction, and we can also give the bone correction. For example, we move to the image of the lung like this. If we use a center, for example, this is the center of the image. If we use maximum, yeah, the AP and lateral will choose the location, will give the maximum values like that. If we use max, we get the effective diameter will be 24.61. This is the lung. And if we apply the lung correction, the dose, the diameter, obviously will be reduced because the presence of the lung. We can see together before the lung correction, the effective diameter 24.6. After lung correction, and we can choose also the lower bound of the bone and soft tissue. We using minus 250. Okay, we will calculate together. This diameter will be reduced. Okay, we will see together from 24.6 to become 15 and 57. And the image is changed. This is only 3 values. The background is 0, the lung is 1, the soft tissue is 2, and the bone is 3. Only 3 gray level in the image. And this is the correction. So the diameter will be less. However, if we implement the bone correction, the diameter will be increased again. Depend on the bone of the patient. For example, we use center without correction. We will calculate again. Using center, the diameter will be 24.37 without correction. However, if we apply the lung correction, this diameter will be reduced to become 20. And if we apply the bone correction, the diameter will increase again. We can see together. Yeah, only small increase of the diameter. Now, this is the technique how to calculate the effective diameter from the image of the patient. The technique I already mentioned is only for one slice. Can we calculate the effective diameter from every slice? Of course, we can calculate the effective diameter for every slice. To do that, we should choose this one. Uses auto z-axis, as mentioned in the CDDA volume. Okay, and then we have the many option. This is the option as mentioned before, and then we also have the 3 options as before: slice depth, slice thickness, and regional. Okay, if we if we choose slice depth 1, it means that slice thickness, that effective diameter will be calculated for every slice along the image. Okay, we will try together. In this slice step, and then this is we choose one, and then we will show the graph. So we will know the graph of the effective diameter. Take one, and then we calculate. The total of the image is 88. Yeah, I think this it takes time. Okay, we will see together. I think it's very fast. Yeah, less than 1 minutes, we can get these values. And this is the effective diameter from slice number 1 up to slice number 88. We can see that at the slice 88, yeah, we can move together like this. Okay. In the slice 87, there is no object in the image. So it is not important for us to calculate this diameter because the image is not available. So if for this case, it is better for us to use regional. So we only calculate from specific slice to another specific slice. For example, we calculate from slice number 2 up to slice number, for example, 85, for example. And then we calculate again, and we show the graph to see the graph of the image. Yeah, this is the effective diameter of the phantom consisted of 88 slices like this. I think it's very simple. And this data actually can be at some line or can be exported to the exported to the Excel file. Okay, we see together. This is the data from the calculation, and then we can add the option. For example, like this, we can add the mean of the Y data. This is the mean is the 17.89, and we can also add the standard deviation of the data like this. Also, we can add the mean in the X data and the standard deviation of the X data. Okay, this is the example, and we can close this line, and we can also save this graph using this plot, save plot. This is we can save with many types of file: PNG, TIFF, JPEG, PMP, SVG, CSV. Then we can also save in the Excel. This is maybe more convenient because we can manage and get something and give something in the Excel file. Okay, for example, we will save this data in the Excel workbook. Okay, and this is the file name, graph of slice, and then maybe we will save in the download document, for example. Yeah, we save together. Okay, this data will be saved in the Excel file. To see our file, we can see this one. This is the our data of the effective diameter, and we can see the Excel. Okay, this is our data. in the Excel. Yeah, of course we can show the graph again in the Excel, and we can also combine another data with to this our data like this. Okay, this is the example of calculation of the effective diameter. Okay, before we discuss again, I will move to another diameter. Another diameter types is water equivalent diameter. This is the most robust of the metric to characterize of the patient in terms of radiation dose, water equivalent diameter. As mentioned before, water equivalent diameter is also can be calculated manually if we already have this value, or we can measure from the image. We will move to the measure the water equivalent diameter from the image. Okay, as before, there are three options: auto Z-axis, and manual. We will initially from the manual like this. Okay, we move to, for example, this image, and we focus on this slide number 11, for example. If we set manual option, there are two options here: ellipse and polygon. Actually, in the APM report number 204, released in the 2011, the APM using ellipse. Okay, we will start from the ellipse. This is the most simple technique for calculating the water equivalent diameter. Okay, ellipse. Click ellipse, and then we have this ellipse. This ellipse can be rotated, can be maximized, and can be minimized. Okay, to rotate using this button, we can rotate this button. Okay, and to maximize or minimize using this button. Okay, and then we set carefully so that this button, so that this ROI is only cover the image and only very small portion other than image, other than patient include to this ROI. We should set carefully. This is the technique from the APM like this. Maybe we can move like this. Okay, now I think it's okay. All patient was included in the ROI, and other is excluded from the ROI. After this, we calculate this one, and then we get 18.88. This is the using the polygon, using the ellipse, as mentioned by the APM in the report 204. And second, this is the more accurate, but more time consuming, of course, using polygon. And if we use polygon, we click this one, polygon, and then we draw the border of the patient point by point. For example, this point, we click one, we click again, until the all image is covered by these points, like this. Yeah, it's of course very time consuming. Yeah, this is manual technique. This is manual technique. Okay. This is just for example. Yeah, if we want to connect the last point to the first point, then we do double click. I don't know. Okay, I clear. Please do double click ya. Ulangi lagi. Okay, diameter, waterfront diameter, image. Sorry, this is manual, polygon, and this is just example, just for example. And then the last double click. Okay. And then we get these values 18.18. And we can also edit this point. We can move to out from the image of the patient or toward to the patient. If this is out, the values will be increased, and this is toward the patient, the values will be decreased like this. We can also add the point by clicking this one. This one, clicking this one, and so on. Clicking this one. Yeah, this is an example. A manual calculation of water equivalent diameter using a polygon. Okay, we clear again. Okay, and the very convenient technique to calculate the water equivalent diameter is using automatic method, using automatic method. And using automatic method, there are many options. Truncated image. This is in this option, we add the correction from the truncated image. This is the largest object only. This is the old algorithm for the IndoseCT. And the new algorithm, we do not use largest object only. And we can also measure the water diameter without ROI or without ROI by removing table. Okay, the first one, I will try to measure the water equivalent diameter for the largest only selection. Okay, I will open the image of the patient. Okay. Okay, we move to the slides like this. Can we see together? Do you see the image of the head of patient?
Yes.
Okay. If we use largest object only, it means that the contouring will be done in the largest object only. In this case, this largest is the head of the patient. So if we calculate this one, the contour will be done in the head area like this. This is for the use largest object only. However, if the largest object only is removed like this, so the contouring will be done to all of the patient part like this. And this is depend on you. What do you want to measure? Using largest object only or using all patient part? This is depend on you. And then obviously this diameter will be different. For the all object, the diameter will be 19.13. However, if we use only largest object only, the diameter decreased to the 15.59 like this. However, this option is depend on you. And how? However, if we only use image like this, this image is only one part. Therefore, by choosing this option or not is similar. For example, if we do not choose this one, we calculate the diameter will be 17. And if we choose this one, the result will be same, will be similar. Why? Because the image is only consisted of one image. However, if the patient image is consisted more than one part, this option is very interesting. But the application is depend on user. Okay, and the second is using truncated image. This is important for the truncated image. I will open another image. Truncated image. Sorry, not this one. Truncated image. Okay. Truncated image. Maybe this one. Oh, yeah. Okay, we move to the this is the example of truncated image. So the image is truncated, is cut in the border of the patient like this. This is truncated. If we calculate without truncation correction, the diameter of the patient will be 18.336. However, if we implement the truncated image, this is correction from the truncation, the diameter will be increased to very small increasing. But this is the correction from the image. And another option, we use largest object only. This is sorry, not without ROI. It is it will get the accurate result without ROI? Maybe. If we back to the equation to calculate the water diameter, there are average value of Huntsville unit and also average also area of the patient. Without ROI, actually the area will be larger. However, because this is the air with city number -1,000, so the area of the air will not contribute to the water equivalent diameter. However, in the image, maybe many high attenuating objects such as table. Therefore, the IndoseCT using option without ROI can be combined with the remove table. So if we using the remove table, and then the calculation will be more accurate compared to without remove table. If we using remove table, and then the table will be erased from the image like this. Okay, this is the option in the calculation of the water equivalent diameter, and actually the water equivalent diameter can be measured in the z-axis as in the effective diameter. Okay, maybe this is all for the diameter calculation. Okay, Mr. Fajar, maybe any question on the diameter of the patient determination?
Okay, sir. Ladies and gentlemen, for the all participant, maybe any question to Dr. Anam?
Dr. Anam, I will ask you.
Oh,
yeah.
Please.
I'm sorry.
Yeah.
Yes, Dr. I'm Yusuf from Surabaya. Maybe I'm missing your explain about the IndoseCT because my wife is trouble and I in out the Zoom. So I'm several missing your explain. Okay.
I'm sorry. I'm sorry. The sound is noisy.
Can you hear my voice?
Yes, but
yes.
not clear.
Okay, sir. And now, can you hear my voice?
Yeah, it's better.
Yeah, I'm sorry, doctor. Yes, Dr. Anam, before that, I'm missing your explain about the IndoseCT. Maybe several explain. And my questions start from when we scanning the patients in this CT scan, we can have the result of the CTDI and DLP in the computer console in the CT scan, right? So the imaging of the patients from the CT scan, we open in IndoseCT and we filling out all of the parameter in CTDI file. So we calculate after that and appear the CTDI volume and the DLP in the IndoseCT. My question is, what the data in the DLP and the CTDI in IndoseCT will be same with the data in DLP and IndoseCT in the real computer console in CT scan? Thank you.
Okay, thank you very much. Unfortunately, in the last, the sound is not clear, but I guess the question. In the IndoseCT, we can calculate the CTDI volume as mentioned before, and also we can calculate the DLP, dose length product. The algorithm for DLP calculation is based on the patient image. The calculation is like this. In the IndoseCT, the first one, we detect the position of the first slice. And then we detect the last position. And then we add the beam width, the beam width of the width of the beam width. So the length of the scan is the position of the first slice and the position of the last slice, and added by the beam width. This is the scan length. And then if the scan length multiply by the CTDI volume, we will get the DLP, dose length product. This is the algorithm to calculate L or scan length in IndoseCT. Maybe this algorithm different from the other software, maybe. So the calculation may be different from one software to another because the algorithm is different. But the differences should be within the tolerance level. I think like that.
Okay, sir. I see.
Yes.
It means the results in the IndoseCT will be
Sorry, the sound is not clear.
Yes.
Maybe you can write on the chat.
Yes, yes, doctor. Oh, yes, doctor. I see, and thanks for your explain. The results of maybe the results of your answer that the CTGI in computer console and the result of the in the city will be not same. Right?
Yeah.
Yes, right?
Yeah, maybe. Yeah.
Oh, okay. Okay, thank you, sir.
Yeah, thank you very much. You're welcome.
Thank you, Mrs. Hosida. Maybe any question for the all participants? Any question?
I think so many options in IndoseCT. Yeah, we can choose what is the most accurate and based on our needs. But we can say that what is the most accurate one? I can say that the most accurate one is to calculate using water equivalent diameter for every slices. Every slice. This is the most accurate.
Thank you, sir. Maybe any question from the all participants?
No? Okay, if no, we can move to the another section. Okay, maybe the all participants can try by yourself in your home on your images, maybe if you have images. And if you have errors or problem, yeah, don't hesitate to email me. Yeah, because I think in IndoseCT there are so many limitations. Yeah. Okay, we move to the another section of IndoseCT. Okay, after we calculate the CDDA volume and we calculate the diameter of patient, and then we can calculate the SSDA. This SSDA is based on CDDA volume, based on diameter, and then we calculate SSDA in this one. Now, it is important to note that if we calculate the SSDA, again, the phantom should be carefully chosen. If we incorrectly choose this type of phantom, the result will be error. The result will be not accurate like that. In SSDA calculation, there are also options. We can calculate based on the AAPM 204, and we can also calculate the AAPM 293. If we calculate the SSDA on the body, the AAPM 204 should be used. However, if we calculate the head, there are two options. What is the most accurate one? I can say that this one is more accurate, 293. This is the most accurate one. This is recently reported by AAPM. I think in the 2019, and APM 204 is published in 2011. So in the head examination, this APM 293 is more accurate. However, if we only choose this one, it's not problem. Okay, we will start from the beginning. I will from this one. We will calculate this one. In the slice number 14, for example, CDDI fall from the diagram. I will calculate only one slice, and then we calculate the diameter. We use water equivalent diameter. We calculate this one, and then we calculate this one based on APM 204. This is protocol. Protocol is important to choose for the effective dose calculation. However, this protocol doesn't give effect on the SSDA, but this will give effect on the effective dose calculation. Okay, and also we can choose the calculation in one slice or in z-axis, as mentioned before. Okay, we choose the calculation in one slice like this, and then we calculate. Okay, like this. We get the values, and if we want to show the graph, we can show the graph like this. Calculate. We can get the graph like this. You see the volume is 6. The water equivalent diameter is 17.9. Conversion factor is 1.9. SSDE is 11.5. DLP-C. This is DLP. C is corrected from the previous DLP, and this effective dose. This effective dose is based on the DLP-C, not based on the DLP like this. After everything is okay, after we calculate everything, and then we can save our data. After we saving this data, everything can we start from the beginning. Actually, this calculation from the beginning to the SSDE takes very short time. In practice, I have tried to calculate the SSDE from 100 patients, and every patient have about 400 slices. To calculate 100 patients, it only takes less than 1 hour. It's very fast, actually. Yeah. But we have known that the every parameters should correctly chosen like that. Yeah. And if we save this parameter, the data will be saved in the database. This is an example of database. Because this contain the patient data, I only glimpse to show you the data like that. Okay, this is the calculation of SSDA. Basically, the calculation of SSDA is very simple. Maybe it takes for every patient less than 1 minute. Yeah. It depends on us. We will try another option or so on. Okay, like this. This is the SSDA. And if we calculate the SSDA in 3 dimensions in z-axis, for example, we use this example of the anthropomorphic phantom. We from diagram, this is all slices. We all slices. We get the slice tube current for all slices, CTA for all slices, diameter, we use a water given diameter, and we'll also calculate for all slices. This is the water given diameter for all slices. And then we can also calculate the SSDE for all slices. For all slices, we can, this one, this is all slices we can show to you. This one. This is tube current for all slices. And this CTDI fall for all slices. And this water equivalent diameter for all slices. And this is the SSDE for all slices also. You can get this graph very fast. And if we and then this box is average. If we choose the Z axis option, this box will be averaged. Average of CTDA fall, average of DW, average conversion factor, average SSDA. This average will be saved in the database like that. Okay, after we calculate the SSDA, it is important to calculate organ dose. However, the organ dose is not safe in the database, and the database only contain CTDA vol, DW, SSDE, DLP, and so on. And the organ dose is not safe in the database. Okay, to calculate the organ dose, there are two options based on the Monte Carlo data. This is based on the database also, or direct calculation from the image of the patient. If we calculate the organ dose based on the MC data, we should carefully this protocol. For example, chest, liver, abdomen, and so on. If we choose body, there are 11 options. And if we choose the head, there are only, I think, 5 or 3 options like that. And then we calculate. This is the graph showing us the organ dose. The marrow, bone, skin, brain, eyes, larynx, thyroid, trachea, esophagus, lungs, and so on. This is the organ dose. And the important thing, if we want to calculate the organ dose directly from the image, it is important to us to calculate the organ dose directly from the image. So we should choose the direct calculation. Direct calculation like this. This is the water given diameter. We already measured before. CTDA volume, SSDA W weighted 11.16 as in here. Okay, and then we can calculate SSDA C. SSDA C, it means SSDE in the center. SSDA P means SSDE in the peripheral areas. And then we can calculate the dose within patient. To do that, we should draw the contour manually in every organ. This is the example. Example, we will calculate the dose at the eye, for example. We should draw manually the eye of the patient. We will do this automatically and in the next version of IndoseCT. But in this version, everything should be do manually. Okay, after we draw the contour of the organ, we will calculate the dose within it. So this is the option also. We can show the water equivalent distance within the patient. We can show this map within the patient. We can show the histogram, and we can show the graph how to measure the SSDAC and SSDAP. Okay, we show all of this option. Okay, and then we calculate. Oh, we should add contour first. And this is the an example. An example. Okay, we calculate. Okay, I think it's a problem here. Okay. Okay. Nah. Okay. Okay, we should start from the beginning. Okay, this is the method for the calculation of the organ dose. And after that, after we have the database stored in the database, we can also analyze our database. We can also analyze. This is a filter. Maybe we gather the data from many institutions, or from many manufacturers, or from many scanners, or from many protocols, or from long period of time. And the IndoseCT will give us a filter. What the data will be analyzed, what the data will be shown to us. This is like this. So we can choose this one. This manufacturer in Toshiba, for example, scanner, Aquilion, Alexion, we choose all. We choose all, for example, all. And protocol, for example, chess. And in this example, we have data, 95 data. We have 95 data, and then
Ladies and gentlemen, maybe any question for Mr. Anam?
Okay, I continue a little.
Okay.
After we set this one, we filtered our data, and then we can show our data in x-axis and y-axis. We can also choose this one. Many options here in the x-axis, for example, this one, for example, DW, and y-axis, for example, CDDF, and then we can generate our data like this. Another example, maybe in the y-axis, we use a frequency. So actually, we generate the histogram. We can also, maybe in the x-axis is age, and the y-axis is frequency. It means the histogram of the patient age, like this. Maybe another example, this is the DW, and this one is SSDE, like this. We can generate like this. This is our data. So we can very easily show our data like this. This is an example. And we can also arrange our data. For example, we will show from the 19 to the 30. Okay, we click right click, and the x-axis, this is from 16 up to the 30, like this. Okay, it's okay, and we can maximize the appearance of our image like this. And based on this data, we can also add the trend line. We can add, this is non-linear, we can add a linear trend line like this. We can move to, we can change to the polynomial, exponential like this, logarithmic like this. And we can also save our data, and also export to the Excel like this. And this is an example how IndoseCT manage our data of the patient. Okay, I think it is all for me. Maybe any question from the participant, Mr. Fajar?
Thank you, Dr. Anam. Maybe any question from the participant? Very nice presentation.
Okay, I'm Mr. Fajar.
Oh, please, Mrs. Adin.
Okay, Dr. Anam said that it is very important to choose a phantom between body and head phantom. Actually, this question at the beginning, before we calculate CTDA4 or diameter, because if for IDA patient, maybe to classify head and body phantom is easy, but how about if we want to calculate for infant or child? Which protocol, for body or head phantom, Mr. Anam?
Yeah, thank you very much. Yeah, using phantom is to quantify the output dose of CT. Actually, there are two kinds of phantom: body phantom and head phantom. Fortunately, we can calculate the patient dose based on this phantom, either based on the body phantom or head phantom. But we should carefully choose the phantom. Unfortunately, the IndoseCT, if we open the image, IndoseCT will identify the kind of phantom we use. But I suggest for you, if you use IndoseCT, to check again. Maybe the IndoseCT will not correctly identify the phantom. So we should check again before we use in clinical setting. In the pediatric patient, there are some tricky. In some vendors, in some scanner, they use body phantom, and in some situation, some scanner, they use head phantom. So if you want to know exactly what is the kind of phantom we use, you should contact to the vendor. This is what kind of phantom do you use? Either using body or head phantom. It is important because everything is begin from this. This is wrong, all are wrong. It is important, I think, yeah, to mention. Okay, thank you very much.
Okay, thank you. Once more, on your analyze that manage the data such as age, the patient age, or on x-axis. Is the IndoseCT can classify about the DICOM information automatically?
Yeah.
Oh, okay. Thank you.
Thank you, Mrs. Andin. Maybe any question from the participant? Any question again from participant? Maybe.
Yeah, we will end maximum 1 p.m. but it is better to end before 1 p.m.
Okay. Any question? If there is no any question, maybe Dr. Anam can give closing explanation or closing statement.
Oh yeah. Thank you very much for your kind attention, for your coming, for your joining, especially Professor Fujipuchi, Professor Arimura, Professor Jarwani, Professor Wahyu Setiabudi, and all participants. Thank you very much for your kind attention. Please use IndoseCT and give us feedback. Yeah. If you have any question, if you have critics, if you have idea, if you have suggestion, don't hesitate to contact me. Especially the basic the database. Yeah. The IndoseCT is very limited in the database, and the type of scanner is very limited. I will be very pleased if you give your data to be integrated in the city. Thank you very much. And I will inform to you also, Alhamdulillah, currently we in the Diponegoro University, me and my student also develop software, another software, sister of IndoseCT, namely IndoQCT, for the image quality. It's very nice. It is now developed by my student, Mas Aris. Yeah, thank you very much for the hard work to develop the IndoQCT. Alhamdulillah, now it's under construction, maybe about 50% maybe, yeah. And we hope in the maybe next year we will hold a workshop on the IndoQCT maybe. We hope like that. Yeah. Thank you very much for your kind attention, and I hope we will join again in another situation. Thank you very much.
Thank you very much for your nice presentation, Mr. Dr. Anam. A very inspiring presentation. According to me, it is not only scientific value, but also human value, a concern for many people in the world. And ladies and gentlemen, if any question, the participant can directly ask Dr. Anam via email, or maybe visit to Dr. Anam's YouTube channel like this. Yes. This is Dr. Anam's YouTube channel. Maybe you can visit and subscribe. Okay. Dr. Khairul Anam, yeah. Khairul Anam in YouTube channel. Ladies and gentlemen, finally we come to the end of this workshop sessions. I would like to thank the speaker, Mr. Dr. Khairul Anam, for their informative and interesting presentation, and of the participant for their very active participation. Finally, applaud the speaker and all of you. Thank you very much. And then I return to nice Master of Ceremony, Miss Indah and Miss Rahma. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Mic-nya.
Halo, Miss Indah.
Okay, thank you very much, Mr. Dr. Khairul Anam, for the presentation and explanation about IndoseCT. Hopefully, it can be useful for all of us and other people, so who can for other people who join workshop today. And thanks to Mr. Fajar has moderated the workshop so it can be run smoothly for today. And I would like to thank for all participants for participation and attention in the workshop from beginning until now. Okay, dear audience, ladies and gentlemen, this is the end of the first day of IndoseCT and PHITS modeling workshop. It's pleasure for us, as well, especially for me, to be master of ceremony in the event. Thank you very much and see you tomorrow. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Waalaikumsalam warahmatullahi
wabarakatuh. You, Mr.
wabarakatuh.
Anam, Dr. Anam, and of the participant.
Okay, thank you very
Mr.
much.
Anam.
And we will meet again tomorrow with
Yes.
Professor Puchi.
Okay, thanks.
So much.
At 8 o'clock.
8 o'clock.
Please
Thank
come
you.
again.
Thank you.
Don't
Thank
forget
you.
to
Okay.
come